Okay, so honestly speaking, the goal with this question paper is to see how fast I can actually go through it. So the point is for me to see if I can, explain and still go through it, at like lightning speed, blah, blah, blah. I'm like, there's a gang load of other papers on this channel where the goal is not like just speed, out of curiosity. Let us see how fast we can do this. Okay. So from the get-go, right? It says here, during the 2019 Rugby World Cup, the South African Springbok players played 7 matches. Okay, the score obtained in each match by Springbok players are given below. Okay, so this is the scores obtained. By what? By by Springbok players are given. Okay, the average score obtained by the Springbok players during the 7 matches they played in 2019 in the 2019 Rugby World Cup was 37.43. Okay, and then for 2 marks, they said show that k is equal to 13. So this is quite a straightforward question because, I mean, like, if you have the average already and you have the data that you were using, all you need to do is to like add it all up and then divide by the total. So everything here, you're going to add it all up and then you're going to divide by 7. And we know that this is equal to 37.43. Okay, let's see. In the calculator, this 19 plus 32. Grab the calculator. Plus 49 plus 57 plus 66. That is giving us 220. What is this calculator saying? 223. And then k plus the 2k there is going to give you a 3k. The whole thing over 7. This is equal to 37.43, right? And I mean, like, on both sides, we can multiply by a 7, multiply by a 7. And then we have here, what? 7 times 37.43. Come on, bro. It's 43, not 47. 37.43 times the 7 there is giving us 200 and what? 262.01, right? However, we know that we can take the 223 to the other side, and then this is going to 3k, right? So this is going to be 39.09 in the calculator, 0.01 in the calculator. Divide both sides by 3. Let's see what it is giving us. In the calculator, we're getting a 13. If you round it off though, 39.01 divided by 3. Yeah, that's going to give you 13.00. So you might as well write it as 13. So that's the answer. Nothing crazy, nothing major. The next question looks like it is asking us for the standard deviation of the data. So it looks as though if you're going to get the standard deviation of your data, you need to, what do you need to do? I feel like if you can just use your calculator, you're going to be better off. So what you want to do is you're going to put all your data in your calculator. And to do that, you're going to press mode. And then you're going to press stat. And then you're going to press the number 1 button, which is going to say var. And then you're going to put all your data in your calculator, you see. You're going to put all your data in there. And then after putting all your data, let's see what it is giving us here. After putting all your data, you have to press the on button. Don't forget to press the on button. And then after you press the on button, you're going to press shift button number 1, shift button number 1, like the actual button number 1. And then you're going to press the var. And then you're going to press, oh, no, not var. You're going to, wait, what? Yeah, you are going to press var. Yeah, var. After pressing var, you press third option, right? It looks something like this. And then the answer there is going to be equal to 18.63. To be honest, I don't really feel like I'm going fast. Like, I feel like I'm strolling. It says the 2 highest scores lie outside P, standard deviation of the mean. Calculate the maximum value of P. Okay. They say the 2 highest scores lie P, standard deviation of the mean. Calculate the maximum value of P. So the 2 highest scores. What are the 2 highest scores? It's 66 and what you may call 57. The two highest marks lie a certain number. Yeah, this is quite an interesting question. The two highest numbers lie outside 2 standard deviation of the mean. So what we know is if you take the mean and you add a certain number of the standard deviation, we're going to get an answer, right? Now, what they're saying is that our two highest numbers, right, they are higher than this number, you see. So our two highest numbers, I mean, like when they say they are higher than this number, they can actually be, this is actually quite a strange question. Okay, not so strange, it's really not straightforward, you know. It's really not that straightforward. But then in this case, if you're gonna have, let's say, two highest numbers lie outside P standard deviation of the mean, calculate the maximum value of P. So in this situation, right, yeah, this is quite an interesting question. Like I'm supposed to be going fast, but I'm bombing out. So funny enough, if these two numbers here, if there's a 57 here and there's a 66 here, one way or the other, our answer here needs to be bigger or equal to 57, you see. Because if our answer here is 57, it means that anything that is equal to 57 or bigger than 57, it will be outside P standard deviations of the mean. So here we can make this equal to 57, and then we can just throw in our value for the mean and our standard deviation. So this is our mean, right? They gave it to us. Our standard deviation, we worked it out to be 18.63. And we know that this is equal to 57. Solving for P here, we're gonna have P, or rather, I mean, like if you write the number first, which is usually normal, 57 here minus 37.43. Let's see, there in the calculator. Come on, calculator. Why are you away from the job? You know, you must work. 57 minus 37.43, right? You're getting there 19.57. And then this is like 18.63p. Gonna divide both sides by 18.63p. No, by 18.63 only. And then you're gonna have here what is going to be the answer. This cancels this, your value of p there is what? 18.63 in the calculator. It's gonna be 1.05. You see. So this is quite an interesting answer. It's also like quite an interesting question, to be honest, because yeah, it is what it is. The strange thing is, you may be thinking to yourself, but then what if you had just made the answer here? Excuse me. You could ask yourself, what if you had just made the answer there a 56 or something? If you had made it a 56, the issue is, wait, hold on. Let me just check in the calculator here. There is 7.43. If you had made that number a 56, yeah, it would also still have worked out one or the other. Because yeah, I think this question, to be honest, it's really quite vague. But then anyways, if you put this value as 56, I think it was also going to work out, because just taking into account these two numbers, right? As long as this number here, or as long as this number here allows you to include these two, then you're good to go, you see. So move on. Let's see. Suppose each score is increased by adding a value of y to each score. Write down the interquartile range of the new data set. So remember, your interquartile range is always equal to Q3 minus Q1. So they said if everything is increased by a value of y. So remember, everything moves up y units. So meaning originally, right, if you look at your data, let's see the numbers here, 1, 2, 3, 4, 5, 6, 7. So this is like Q2, then 1, 2, this is like Q1, and then this is technically Q3, like here, see. So the idea is your original Q3, right? Original, no, your original interquartile range is just 57 minus 19, which is 38. Now the issue is if all these numbers, if both of these two numbers move up by the same distance, the distance between them is still going to be 38, you see. So here the interquartile range is still going to be 57 minus the 19, which is 38. The reason is, I mean, like if you think of it logically, if you increase this number by 2 and you increase this number by 2, your interquartile range is still going to stay the same. You see, 57 plus 2, if you subtract 19 plus 2, you're still going to have that 38 there. So that's how we're saying here the interquartile range stays exactly the same. That's why it's only a 1-mark question. Moving on. Calculate the value of y if the lower quarter of the new data set is 30. Calculate the value of y if calculate the value of y if the lower quartile of the new data is 30. So the lower quartile is 1. So the original lower quartile, let me just write it like this, The original Q1, as we see in our data here, or the original one is like 19, right? So if they're saying that the new one is 30, I mean, from 19 plus y, if you're going to get a 30, I mean, like y here is just what, let's see, 30 minus 19. It's just going to be an 11, you see. So this paper, you can see, it just has questions that are just a bit strange, but they're not weird or anything. They're just different, you see. So that's what we want to keep in mind with this kind of a question. That's just question 1. Let's move on to question 2. Question number 2, it says, a town has 2 popular municipal swimming pools, namely the Madiba swimming pool, okay, and the Kronje swimming pool. The table below indicates the number of people that visited the Madiba swimming pool over a period of 8 days. The corresponding maximum daily temperatures for each day is given in the table. Okay, so maximum daily temperature, right? It goes up to these days here, different temperatures, okay? And then the number of visitors. I mean, like this, you want to always think of these kinds of questions logically. When I say you want to think of them logically, I literally mean that if you look at it nicely, all that's happening is the higher the temperature, the more people that are going to be coming to these swimming pools, So that's the issue here. For 3 marks, they say to determine the equation of the least squares regression line. So determining the equation of the least squares regression line, you have to use a calculator. So the first thing is you want to clear your calculator, meaning you have to press shift and then the number 9, which is to clear your calculator. And then now you have to press mode, and then you have to press stat, and then you're gonna have to press the option 2, which is like a plus bx, and then you're gonna have to put 2 columns here. There's x and then there's y, right? Let's actually put that data. Yep. Okay, so all the data is in the calculator now. All you have to do is you're just gonna then press the on button. Don't forget to press on, because yeah, I do get questions a lot where people say it's not working, but I asked them, did you press the on button first? And then they're like, nope. So here, after you press the mod on button, you're gonna press shift. You're gonna press the shift, and then you're gonna press the number 1 button. And then you're gonna press the number 5 button, which says reg. And then you're gonna press the number 1 option, which says A. Of which the number 1 option for A is gonna give you negative 106.95. Let's do the whole process again. B is equal to 14.76. So therefore, y is equal to, remember, this is the equation of the least squares regression line, of which your A value is negative 106.95, your B value is 14.76. Perfect. Now we can move on. You see, I want us to get the correlation coefficient. So you're gonna do the exact same steps, right? but from the shift. You're gonna press shift, the number 1 button. Let's see here, shift number 1 button, and then you're gonna press reg, and then you're gonna press the option 3, which says R, of which that is giving you 0.94. Nice. You keep moving forward. You keep moving forward. A manager of the Madiba swimming pool asks a grade 12 learner, Jan Briat, to predict how many visitors can be expected on a certain day with a maximum daily temperature of 32. Jan Briat predicts that 365 visitors can be expected on that day. Should the manager take this prediction seriously and prepare for 365 visitors? Motivate your answer. So the easiest way to motivate your answer is to use a formula. You see, because the formula, remember, your least squares regression line equation is there to be able to, it's literally there to help you predict these things. So I forgot to put X over here. Oopsie. Uh-oh. Well, maybe I wrote it down, but then it was out of the page, so it didn't write out. Nope, it wasn't. Otherwise, it would have shown there. Oopsie, that's the way. Let's see. So let me copy this thing here. So we need this formula, and we need to throw in stuff into this formula. So into this formula, let's see what we can do, right? It says y is equal to negative 106.95 plus 14.76. Okay, wait, no. This is the temperature. So temperature would fall under the x, right? Let's put a 32 there. Let's put this in the calculator. So in the calculator, we're getting here 365.37 visitors. However, this is going to be there for 365 visitors because you cannot have, a 0.37 visitor. Maybe there's a pregnant lady that's going to come there or something. But then she's not there to swim. Maybe she's just to chill outside the pool. Hey, but that's just being too extra, So yeah, visitos. So yes, he's correct. Yes, the prediction is correct. Prediction is correct. I keep writing and then not having enough space because I cannot see where the blackness ends. What am I even saying? Anyways, let's see. 2.4, right, says over the very same period of 8 days with the exact same daily maximum temperatures, the Cronje swing pool also recorded the number of visitors for each day. The equation of the least squares regression line for the Cronje swimming pool is given by this. Okay, which swimming pool had the highest number of visitors over the period of 8 days? Motivate your without any calculations. So obviously, if you think of the equation, right, y is equal to k plus 12 over 8 5x. The thing is, this 12.85, it's almost going to represent some kind of a gradient, because remember, this equation is somewhat an equation of a straight line. So in this case, we can see that the gradient of the Madiba swimming pool is higher than the gradient of the the Cronje swimming pool. So here, what we can say is 12.85 is a gradient that is smaller than 14.76. So the Madiba swimming pool will which has number of visitors. Yeah, so the Madiba swimming pool will have more visitors. More visitors over a period of time. You see, so that's basically the big idea here. You see, you're just gonna mention the gradient And then you're going to mention what else? Yeah, we mentioned the gradient, and then we mentioned whichever one is going to be a bit higher. So this is good enough. Now you may be thinking to yourself, but then for 3 marks, would you not want to say more? Not necessarily. This is good enough. So yeah, wait, wait, this is a gradient that is smaller than this, blah blah blah. Yeah, so this is good enough. Let's move on to question number 3. Question number 3. What do we have here? Yeah, question number 3 is quite interesting, right? Or is it? It looks quite straightforward, actually. Oh, we'll see. Let's see. It says in the diagram below, A is this. So we have A up there. B and C are the vertices of ABC. Interesting. And then it says with C a point on the x-axis. So C is a point on the x-axis. Okay, yeah, that's good. Then D is this point here. We only have the x value, we don't have the y value. And then lastly, they have told us that E is this coordinate over there. Okay, that's interesting. Whew. They told us that these are the midpoints of these two lines here. And then they said KC is equal to 16 units. Where is KC? KC is 16 units. Okay. Well, this is quite interesting. So if KC is 16, right? And you're seeing that this x value is like negative 20. It means that from here to there, it's 16 units. And then from here to there, it's like 4. You see? Because from this is representing 0, you see, because they're clearly showing you that this is the y-axis. So from 0 all the way there, it's 20. So if KC is 16, this has to be 4. So automatically we have the coordinate of 4, which we may need, the coordinate of C, which we may need. So anyways, let's just see the first question. For 1 mark, they said we should calculate the gradient of AK. Where is AK? AK, we should calculate, no, the gradient of AK is undefined, yes, because this is going to be a 90-degree angle. So if it's undefined, it means that this line is exactly going straight downwards. Write down the equation of the line AK. So the equation of the line AK is going to be x is equal to negative 20. Because as long as a gradient is undefined, it means that it's a straight line going straight downwards. If your line was like this, then your gradient would be a 0. Anyways, calculate the x-intercept of the line AC. And we already spoke about it, right? With AC, the x-intercept, we are showing that it's a negative 4. That's why this is just the 1 mark question, you see, because we really didn't have to think too aggressively. We just had to think logically. So I think having to have, guessed that this is a line going straight downwards, it's just, I don't know, intuition, I guess. So the next question here says calculate the length of AC for 2 marks. That's quite simple. It looks like we can just use Pythagoras theorem because we have technically A and K. We have AK based on the Y value of A, which is like 64. So this is like 64. And then here we have this as 20. So yeah, we can just use Pythagoras here. So AC squared is equal to AK squared plus KC squared. Nice. This is very, very nice. It's very good. It's very nice. It's very fantastic. We are allowed to RC it. So with this Pythagoras theorem, like there's really nothing crazy here. We're just going to have the 64 squared plus 20 squared, the whole thing under square root. This is our value of AC, right? And then what else? That's the way you like it, right? Yeah. So what is this now? No. This is not a 20, bro. It's a 16. Come on, man. No, wait. Yeah, why did I put a 20 there? I meant 16. Oopsie. Yeah, so this is what we have. And then this is going to give you, under square root symbol, it's going to give you 65.97. They're going to give us 2 marks for that. Nothing crazy. They want us to show that P is 32. Where's P? P is the midpoint of AC. So, that one is really not going to be an issue. So the midpoint formula, right? We know that it's going to be the X value of the first line plus the second one, Y value, So here, we're going to have the negative 20 plus negative 4. Negative 20 plus negative 4. and then there on the y value, we're gonna have 64 minus a 0. So it's like 64 minus 0 over 2. And then, I mean, like your midpoint, which is D, the x coordinate, we don't know. No, the x coordinate is negative 12. Like it's clearly there. And then the y value is going to be at 32. I don't even know why I did both sides because we only need the y value. So this is quite dumb. P is equal to 32. So determine the equation of the line AB. Where is AB? A is over here, B is over there. Okay, quite interesting. So with AB, the one thing is, remember, this is where your theory comes in, your theory of your work. In this question, right, you need to know that the line AB is parallel to DE. They are parallel to each other because there's a law that states that if one line if a line inside a triangle cuts two sides of your triangle in half, then it means that that line is parallel to the third line of your triangle, and this line is going to be half of the third one. You see, two things come out from your theorem. So anyways, here we're going to say, firstly, we're going to state that D what? It's the line DE. DE is parallel to AB. The reason is midpoint theorem. You see, now that we have stated that, we just need to get the gradient of DE. So the gradient of DE, we can just use the gradient formula, you see. So using the gradient formula, what do we got? We have got, we can see there, it's gonna be 26 minus 32. Let's see there. 26 minus 32, and then the x values there, it's gonna be 9 minus 12. So it's like 9 minus 12, you're gonna have to plus the 12, you see. In the calculator, let's see there, we're gonna have the negative 2 over 7. Okay, that's the gradient, right? So as soon as we have the gradient here, we know that we need a coordinate that the line passes through. And then bingo, it's negative 20 and 64. Because remember, even though we get the gradient of DE, it's exactly the same as the gradient of AB. You see, because they're parallel there. Fantastic. So here, therefore, y1 minus y1, and then x minus x1, and then here you have y minus, what are the coordinates? We had negative 20 and 64, right? So it's like 64 here, gradient, we have negative 2 over 7, and then 20. Nice. So it's negative 2 over 7 here, minus what? Minus 40 over 7, and then like y minus 64. Everything on one side, you have negative 2 over 7x. Negative 40 plus 64 is going to give you a 408 over 7 in the calculator, because remember, it's just a calculator, 40. Yeah, so I think you have to clear your calculator also after what you may call using the whole stat stuff, because yeah, it's always going to be doing some funny stuff when you don't clear it. So 6.3 is a 5-mark question. I mean 3.6 is a 5-mark question, but not because it's like long. It's a 5-mark question because you have to be creative. So they're asking for KAB. So where is K? KAB. So KAB is the angle here. So the angle here, the one thing you want to recognize is that this angle here, you want to be strategic when you get this angle, because remember, when you use this formula tan theta equal to m, it's only going to give you an angle of inclination with the x-axis, or rather, it's actually only ever going to give you an angle with a horizontal line. You see, the line has to be horizontal. So what you can do for yourself is you can literally put a horizontal line here for yourself. Like legit, it is 100% legal. So let's change the style of this line. Let's maybe make it a bit thinner. Must lose some weight, go to the gym. So let's see here, what you call, it's not body shaming, guys, it's just facts. Anyways, Okay, yeah, let me not be that guy. So this is like negative 20 coordinate 64. So what you can do for yourself is clearly if you want this angle here, right? It looks as though if you look nicely, right? This is where your creativity is, is needful. If you look nicely, this line here, you technically have, let me make it thinner also. Come on, bro, come on. Where's the color white? We want to make it super thin. I'm not saying thin. Okay, forget me and thin and whatever. I'm just going to confuse people here. Let's see. Here, let's just try and make this like a straight line. So the idea is, if you look at this line, line AB, if it's going to be extended like this, then what you can already see is that all you need is to get its angle of inclination, you see. So the angle of inclination that you can work out is this whole angle here, you see. You can work out that whole angle, or you can just get this portion here, you see. It doesn't matter. Your angle of inclination formula can get you either of those two, because if you get the acute angle, which is what you always get, to get this one, you can just remove it from 180. But if you get this tiny angle, we know it's going to be the same as this tiny angle over here, you see. So funny enough, using our angle of inclination formula, if we get this tiny angle here, we can actually just say, we can actually then just say 90 degrees, because remember, this is like a 90-degree angle, right? So if you get this tiny angle, this side is 90, this side is 90. So if we get this tiny gray angle here, we can just say 90 minus this tiny angle, and we get the green one. So that's going to be what we are going to do. So let's do it, right? So shift 10. Oh, we need the gradient of AB. What is the gradient of AB? The gradient of AB, we worked it out to be negative 2/7. So shift 10. So let's do here shift 10. Wait a minute. Shift 10 is equal to negative 7/2. No, negative 2/7, bro. So we need to get a reference angle first. It's like shift 10, negative 7, negative 2/7. Woo! You're being too fast, man. Relax. Relax, my guy. Relax. So shift 10. Oh, no. When you get a reference angle, you don't have to use a negative. You're gonna mess things up. So 2/7 there, all nice and dandy. You see, we're getting something that looks normal. It doesn't look crazy, this answer. It looks very normal. So this is like 15.95, of which the 15.95 that you're getting is this angle here. This is what's 15.95, you see. There we go, 15.95. So as long as you have this 15.95, it's easy peasy lemon squeezy now, because now you can say, therefore, KAB, is it KAB? Is equal to 90 degrees minus the 15.95, right? This is going to be equal to 90 minus our answer. That's going to be 74.05. So you can see here, you're basically getting rewarded for thinking creatively. Because if you don't think creatively, you're going to end up overworking yourself, and that's not something you're going to get marks for anyways. So KAC, they said if KAC, where's KAC? We need to get this picture again. They are talking about angle KAC. They said if KAC, let's see it first before we even carry on reading the question, because we want to know what we're dealing with. KAC, what? Oh, this tiny angle. They said if this tiny angle is 38.67, determine the area of ABC. Yeah, that's quite interesting. Wow. Well, here we have it as 74.05. I don't even know why they gave us this angle, to be honest, because it's like, why would we need that angle? Did we get the coordinates of B? Nope. Did they ever ask for them? I don't think so. But getting the area of ABC, the one thing you want to recognize is, we have quite a lot of information, because we can use the area rule. We can use we can use so many things. Like we really can use so many things, you see. We really can. So I'm even now thinking to myself, bro, like we have like, let's just keep it simple. Let's just use the area rule. Because why not, you see. So if we're gonna use the area rule, we need at least two lengths. We need two lengths, as in two distances. And then once we have those two distances, we can then we can then just use our formula. But in this case, it looks as though for us to get the distances of at least two sides in our shape, we at least need to have at least the coordinates of B. Because, oh no, we don't have to have the coordinates of B actually. It doesn't matter because we want the length. The fortunate thing is this is equal to that. So if we get EC, we easily get EB, and then we can just double it, you know? So we really don't need the coordinates of B. We just need the distance of BC, and we also then just need this angle here, you see. So yeah, let's see how we can get this angle. But it looks like we're gonna be doing some long dry stuff, some long dry things, you know, because if we're gonna get this angle, then we're gonna need these two angles of inclinations here. So that's a way to do it. I mean, for 6 marks, let's just do that. You know, let's just do that because why not? You know, why not? So yeah, let's. What am I even skeptical about? I really don't know. CAB, CA. Where is CAB? Wait a minute. What is going on here? I feel like no. I'm making a mistake. The whole in the previous question, this whole angle here is 70 something point something. Oh, I don't know why I'd put that tiny thing there because it really did not help anything. You see, it really did not help anything. But then let's just do what I'm thinking. Let's just get this angle of inclination here. So to do that, we can use the gradient of CE. So here, shift 10, angle alpha, we know that it is equal to M. Using the gradient of EC, the gradient of EC, what is it going to be? It's like C is like -4 and 0. So it's like 26 minus 0, 9 minus 4. What we're going to get here, 26 divided by 9 plus 4, right? It's going to give you a 2. Nice. So this angle here, we can say, therefore, shift 10. No. I always say get the reference angle at first. I'm trying to be consistent, you know? So our reference angle here is going to be shift 10. Shift 10 with a 2. Let's see, shift 10 with a 2. You are going to get 63.43. Yeah. But then this is an acute angle anyway, so we might as well just take that as our answer. 63.43. I do feel like this is along the right, to be honest, but you know, gotta do what you gotta do. And then we need to get this tiny angle over here, right? We can also do that using our angle of inclination formula. So let's see here. Tan theta is going to be equal to M, the gradient of, we can use AC. So using the gradient of AC, we don't have. So let's see what it is, 64 minus 0, 64 minus 0, and then you have -20 minus 4. -20 minus 4, right? So it's like 64 divided by -16. Gonna have -4. So here, therefore, your reference angle, your FEF angle, bro, it's ref. It's ref, bro. Your reference angle is got to shift 10, 4. And then what does that give us? It gives us a these were alternating. Wait, what? Yeah, I'm getting carried away here. So it's like 74.96, right? That's an acute angle, so we're gonna take that as theta. Wait, what just happened here? Oh, what did you just write down, bruh? Reference angle is gonna be equal to 75.96. And then this is an acute angle, so yes, it's definitely the one for Our theta is because your answer is just going to give you an acute angle. So this angle here, we can then say, therefore, 180 degrees minus 75.96 minus 63.43 is going to be equal to what? 180. Yeah, this does feel like a long dry, but then the issue is here. Yeah, we would not want to waste time thinking of some fancy method and instead of just doing what is in our faces, you know? So this is like 40.61. There we go. Let me maybe even bring this down here so, you know, to make it look all, you know, all together and all that stuff, you know, maybe. Anyways, let's see. So with this angle, now the distance, doggo. So much work. Yeah, to be honest, this does feel like way too much work for like just some small marks. It feels like way too much work. It really does. It really does. But to be honest, like if you have gone this far and what you're doing is gonna give you your 6 marks, you might as well carry on and just finish, you know, instead of, you know, crying about it and all that shandies. So yeah, man. Let's see, unless I missed something in the given description that was gonna help us get B. KC is 16 units. E is this. Nah, oh snap! We could have gotten B using the midpoint formula, because this is like the middle, right? So you have the one side, you have the middle, so you can easily get what you may call B. And then once you have gotten the coordinates of B, you could have just used this angle here for the sine rule. Oh, bugger. Snap. Well, I didn't think of that in time, you see. So this is me trying to show that, okay, fine, if you don't think of it in time, I mean, what can you do? You see, you can't scrape everything. You just have to, you've made your bed, so you just gotta lie in it, you know? So let's get the distance of AC because we have no choice, you see. Wow. Well, let's get the distance of CE first. So distance, CE, right, is gonna be equal to square root. It's gonna be -4 minus 9. And then you're gonna have the 0 minus 26. And then what? So this is like -4 minus 9, right? And then this is like squared. So that's like 169. And then 26 squared is like 676. And then what? 169 there, 676 there. That's like 13 square root of 5. You see, it's all good. It's all good. Let us keep it moving. So what we, oh, no, goodness. We have to times it by 2. Yeah, this is a purely long dry. I don't even want to lie. So, ish. Yeah, ladies and gentlemen. Yeah, man, gotta do what you gotta do, you know, gotta do what you gotta do. So, what is it now? 50, I feel like I'm messing up again. No, I'm not. So this is gonna be 26 square root of 5. That's BC. So AC, let's get the distance of AC. It is just gonna be -20 minus 4 squared, and then 64 minus 0 squared, and then what? Let's see here. -20. What are we getting now? We're getting the distance of AC. So the distance of AC, come on, Brody. Use that calculator. Don't be afraid of it. So I'm just putting all this in the calculator. Just trying to see what it's going to get us. Let's see there. So it's like -20 minus the 4, right? So you plus. And then 64 minus the 0. And then you plus. Yo. Yeah, it is what it is. It's 16 square root of 17. 16 square root of 17. So with all this being done, we can say therefore the area is going to be a half. One side here is 26 square root of 5. The other side is 16, 17. and then the angle is like 40.61. So everything seems to be fine, I guess. I mean, maybe I'm just being paranoid. But anyway, this is 1248.22. Moving on to question 4, it says the following. In the diagram below, the equation of the circle with center F is this. Okay, so this is not in standard form, it's in a different format, but it's for this equation with center F. And then they say here, the equation of the circle with center M is this. So this one is in standard form. And then they say the point K, right? It is, where is K? K is this point here, 9 coordinate -10, right? It lies on the circle with center F. And then it says here Jn, where's Jn? Jn and KL, these are tangents to the big circle. And then it says F is a point on J. No. F, Jn and Kn are tangents to the circle F, yes, at the points J and K. Then it says the 2 points are touching externally, or the 2 circles touch externally, so they touch here externally. Okay. Seems like there's a lot going on with this sketch. We can already anticipate, these interesting questions. Write down the length of the radius of the circle with center M. So the radius of the circle with center M, we're going to get it from here. Not to say 25 is the radius. Nope. This standard format shows us that r squared is equal to 25. Because remember, the equation of a circle, if it's going to be in standard form, then it's going to look like this. So where the 25 is, we have r squared there, which is just giving us a 5. Because if you're going to square it both sides, then you're going to get a 5. Nice. So you now know that this distance here is like a 5. This distance is like a 5. Okay, maybe that's going to be useful. They want us to get the coordinates of F. F is the center of the big circle. So getting the center of the big circle, it looks as though you may need to take this standard form, and you need to take this format, right? And then you need to write down the equation of your circle in standard form, because as long as you do that, you're going to be able to see what the center of your circle is. Of which, getting the equation of a circle in standard form, you can just check that on the main channel. And then just check in the analytical geometry playlist. Then you will see there's a tutorial on putting an equation of a circle in standard form. But I mean, like, we're here now, so we can already just do it. So to do that, you have to group the x's together. And then what you do is, once you've grouped the x's together first, you have to work out the value b over 2 squared. So for the x's, or rather for the value of, so what I mean by, you have to work with these two together, right? First. And then this, we consider it the b value of these two. This is the b value, so it's like 6. So this value here is just 6 over 2 squared, which is just 3 squared. Don't square it, just leave it like this. So you're going to add this 3 squared over here, right? And then you do the same for the y's. So you're going to have here your y squared plus your 4y. Now for the y's, same idea. Your b over 2 squared is just 4 over 2 squared, which is just 2 squared. Don't square it, just leave it the way it is. So let me write here with a different colore, 2 la 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 la. So this, though, because you added these two numbers on the left side of your equation, you have to add them as well on the right side, you see. So let's just add that over there. Let's just add that over there, you see. So what we're doing here is we're trying to put this in a format that we can eventually factorize. So what you do is these first three, right, you literally just write them in one bracket where you have x and this number inside here. If it's a +3, you're going to put a plus there, then you square it. So these three are replaced by this bracket, because if you factorize this expression, you end up with this. You do the same for the y's. This and the 2, you put it in brackets squared. When you factorize this expression, you just get this, 2 brackets that look alike, where it's y plus 2. And then on the right hand side, you can just put that entire thing into your calculator. Just put that whole thing in your calculator, and then you will be good to go. Let's see, in the calculator, 9 plus 4 That's like what? What is 9 plus 4? 9 plus 4 is like 13. 13 plus 87 is like 100. So here you can see, therefore, your center is just -3 and no, hold on, I forgot here. This is a -6. Ooh, good Lord. Oopsie. Had made a good mistake. A good mistake. So that is not good. I only noticed here, I was like, something doesn't seem right, because the x value here is a plus. And no. The x value is a plus, but the y value is a negative. So it really wasn't going to work if the x here was a negative. So is good. So that's F, right? For 2 marks here, they're asking for us to write down the length of the radius of the circle with F. Radius, you know that r squared is 100. Therefore, r is equal to 10. Because we said that in the standard form, this is actually r squared, you see. So nothing crazy there, nothing major. What else? For 2 marks, for 4 marks, they said, show the calculations that h is equal to square root of 104 minus 2. Where is h? H in the expression, I feel like we have to copy the sketch because I'm like scrolling up and down. Hey, it's not nice, man. It's not nice. We are not as keen on doing that. So let us just do what we gotta do. Let's crop this thing here. Where is H though? H is what? What are they talking about when they're talking about H? Maybe it's in the description. Is it? Uh-oh. Maybe it is. Maybe it is. Let's find out. In the description, where do they mention anything about H? Oh, it's the x, it's the y value of the center of the smaller circle. Wow. Okay, that's interesting. That is like super interesting. Well, the fortunate thing is, yeah, with this kind of a question, you really don't need to panic, because if you panic, you're going to cry. You are really going to cry. Now, the fortunate thing is, where 2 circles touch, right, their centers will always be aligned. Like, it's just how it is with the circle. It can even have touched over there. Your centers would still be aligned, you know? So what we now know is, firstly, what is the coordinate here? It's 3, coordinate -2. The one here, we know it is, x value is 14, y value is h. Now, what we know is we have the radiuses of the 2 circles, right? So the radius of the first one here is like 10. And then the radius of this is like, we worked it out to be a 5. So the distance there is just 15. So it looks like we can use the distance 15 to help us do what we gotta do, And then we can just get h. So that question is actually quite straightforward. I don't know why I was not, writing out what I was writing out in this sketch in particular. I don't even know why I was doing it in that other sketch, because now I'm like, bro, you now have to like do double work. Like, look at what you're doing. So unnecessary. But it is what it is. Here we are. So in our distance formula, we know that the distance is 15, or rather, let's just write down the formula. Fm is equal to square root of x2 minus x1 squared, y2 minus y1, y2 minus y1 squared. Okay, so what you get here is like square root of like 3 minus 14, and then you have the -2 minus h, -2 minus h, right? And then you're gonna have here 3 minus 14. What is 3 minus 14? It's like -11. And then what is 2 minus h? Whoa. This is equal to 15, 15. 2 minus h, like you don't have anything there, so you have to kind of expand that one. Square both sides. What is 15 squared? Did I just say 15 squared? 15 squared is 225, bro. 225. What is what you may call? These cancel each other, right? The square and the square root. So what is 11 squared? 11 squared is like what? Isn't that like 121 or something like that? Something crazy like that. Yes, my friend, it is. So 121. -2 times -2, that's like a 4. This and that, that's like a positive 2h. Another positive 2h, and then an h squared. And then you have here 121 plus ooh, plus 4, that's 125, bro. And then there's 4h, h squared, 225. So we can just put everything on one side. It looks like we're gonna have there a quadratic equation. Yeah, I feel like I went the long drive, but here we are. Here we are. H squared plus 4h, 125 minus 225 is like 100. 100, yes, is 100, but it's going to be a negative 100. So let's solve for h here. H is equal to negative b plus minus b squared minus 4ac all over 2a. What is a? A is a 1. Therefore, h here, yeah, ne? It's quite interesting. Well, at least we know what we're supposed to work towards. So if our answer does not look like what we're supposed to get, then yeah, we're going to, we're gonna have to go back to the drawing board. We have to go back to the drawing board. But anyways, we're getting negative 2, blah, 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 blah. Okay, so this is 8 point something, something, something. Yo. Oh my goodness, this is like so not good. Well, I'm getting here negative 2 plus 2 square root of 26. In the calculator, this is a positive number, but now we need to write it like this. So this is like, okay, that's quite interesting. So what I would do is, you see here you have 2 square root of 26. So the idea is these are two things being pasted together, right? So what I would do is I think you can put both of these under a square root, right? Because remember, you're trying to get h is equal to square root of 104 minus the 2. So our minus 2 is already sorted here. Perfect. This thing, we have to show that it is equal to square root of 104. So if you're going to put both of these under a square root, this you would need to write it as something under a square root, of which 2 is just square root of 4, right? So you can put there square root of 4 and then 2 into 6 there. They are both under a square root now, so you can just say 1 big square root and then 4 times 26 and then negative 2 there plus square root of 104. There you go. 104 minus 2. Whew. Yeah, ne? Life is interesting. Life will be a dream. Life could be a dream. Let's move on. 4.5 says, show that the equation of the tangent Jn is this if J is this coordinate. Oh well, let us get our picture, because if you can see your picture, you will be able to answer the question easily. So where's Jn? There's Jn here. So they want us to get the equation of Jn. They've given us the coordinate of J, which is good, I guess. Not I guess, it is good, because remember, whatever we know, Jn is perpendicular to the radius line there, because that's just how it is. A tangent will always be perpendicular to the radius. It's a law. Laws are meant to be followed. Yeah, unless somebody breaks into your house, and then you need to fight. What am I saying? What the hell, bro? Yeah, I live it off ramp. So f here, we got it to be like 3 and negative 2. So what you can do is, remember, you want the equation of a straight line, which is Jn. So the equation of a straight line, it's like y minus y1, x minus x1. So the good news is you just need a gradient and a coordinate that the line passes through. So the coordinate, we have that sorted. We just need a gradient, of which a gradient, we can just use fj. So fj cruiser. The gradient of fj is going to be like negative 2 minus 6, 3 minus 3. That's like what? Negative 8 over 9. So therefore, the gradient of Jn, because it is perpendicular, it is going to be, let's just use the formula. We're going to multiply the two gradients, you see. They're going to equal to negative 1 since they're perpendicular. So the gradient of Jn multiplied by this negative 8 over 9 is equal to negative 1, right? And then what we know is here we can divide by negative 8 over 9, ka-ching, negative 8 over 9 as well, right? And then this is like gradient of Jn is going to be equal to 9 over positive 8. Whew. Therefore, y minus y1. y1, we said it's a 6. It is equal to the gradient, and then x minus x1 is going to be like a 3 there. Because negative and negative 3, you put a plus. This you're going to multiply inside your thingy. This you're also going to multiply. And then the 6 comes over. Yo, I'm not even looking. Is the gradient 3 and 4? Oh, it's just going to be simplified. Yeah. No, but there's a 3 on top. Yeah, man, come on. It's fine. Wait, it doesn't seem right though. What? Come on, bro. Uh-oh, what just happened? I made a mistake. I made a big boo-boo. And the thing is, I'm always just cruising and cruising and cruising. I'm not even looking. When you don't look, that's when you mess up good, like I just did here. Let's see, negative 2 minus 6, that's negative 8. 3 plus, bro, it's a 6, not a 9. I feel like you were all looking and you're like, bro, what the hell is going on? Snap, I messed up good, eh? No, bro, come on. It's, oh man. The 8 and the 9, wow, what a classic fail. So this is going to give you negative 4 over 3. And then here you would have put a negative 4 over 3. And then negative 4 over 3. Negative 4 over 3. And then here your gradient would have been 3 over 4. I should have just checked. Man. And I've gotten so far and I'm like, okay, awkward. Now we have to go back and put all those gradients. How embarrassing. But it is my fault. I am kind of rushing anyways. And I'm thinking to myself, bro, why are you rushing? Like, why are you even rushing? Is someone going to give you a watermelon when you're done running? And the answer is no. And why even a watermelon? Like, what the hell? I don't know. And I'm still thinking to myself, is what you're writing even correct though? I hope I'm not like, I feel like I messed things up for myself and I need to like really double check nicely here. But I think everything is fine because this is going to be, this plus this gives you 33 over 4, which is what we have here. So, okay, I guess we messed up a bit, but, we're back and in full, whatever, full force. A line LN passes through the center. It feels like with this sketch, we need to have it following us, because if we leave it alone, I don't see good things. I only see not good things. Get it? Good things, not good things. That's dumb. Yeah, excuse me. Try jokes, my guy. Try jokes make the word go around. Or they make the word stop. Yo, we're busy doing math. Let's see. A line LN. Where is LN? A line LN passes through the center M, right? Such that LN is parallel to JK. Oh, nice. Very nice. If they're parallel, it means that this is 90 and this is 90. So what now? The line with center M is translated. Ooh, translated. It's like moved along the line LN. So meaning they're moving this circle, right? So meaning this circle can be like somewhere there, it can be like somewhere there. That's what they mean. So that circle is translated along the line LN. Oh no, oops, I lied. M, yeah, it's the center, it's what? The circle with center M is translated along the line LN between the two tangents of circle F. Between the two tangents of circle F. Okay, for the interval X is between P and Q. Oh, I didn't lie. Yes, they just mean that they're going to be moving this circle up and down, you see. So meaning you have this circle, né? So let's just make it smaller. Make the circle smaller. So this circle here that we have made smaller, this circle here, they're going to move it, up there. No, they say they're moving it. They said what the circle with center, blah blah blah, is translated along the line ln between the two tangents of f. Okay, between the two tangents of f. Okay, for the interval where your x value is an element of p and q, give the minimum value of p such that circle M will not intersect the tangents to the circle with F when translated along Ln. Okay, well, this question, all they mean is, right, if your circle is here, this is the original place where your circle is, right? Now, what they mean is, what's the furthest you can move it and your circle won't be touching your tangents? And then what's the furthest you can move it and your circle also won't be touching your tangent here? So that's what we need to do. So the easiest thing is you just want to think to yourself, okay, fine, if your circle is all the way here, right, what will be the x value that it would have been moved to the left? And then if it's somewhere down here, you want to ask yourself what would be the x value that it will have. Yo, dude, you're saying something, it's making sense in my head, but I feel like I need to say it again, and I also do feel like I need to read the question again. Determine, give the minimum value of p. The minimum value of p. Wow, bruh. Wow. But then this question is annoyingly vague. When I say that this question is annoyingly vague, I'm referring to things like how this x value that they're referring to here, I mean, are they talking about the x value of the center of the circle, or are they talking about the x value that it will be when it's up there? Or it's just one of those questions that are annoyingly vague. So I would safely say that if you find a question like this in an exam, the best thing you can do is to make sure you finish the whole paper first before you can even bother with these nonsense kind of questions, because it's like, what the hell, man, just be clear. But let's see. A line ln passes through the center. Okay, so since they're talking about the center, right, we can try and focus on the x values of the center. So with M, the x value of the center, let's see originally what it is. According to our given description, the center is -14. And then we also got H, right? H was, what did we get as H? It was, yeah, that other number there. The 100 and whatever. Whew. So let's start there. So M is like 14, and then square root of 104 minus 2. Okay, so this is the x value of this is the x and y value of the center, right? So that is quite interesting. Is it really interesting? Maybe not. It really doesn't seem that interesting. It just only seems a bit weird. Yeah, it really does. It really does. It really does. But let's see. Since we're dealing with Ln, right, what we know is that Ln, everywhere on this line, you have coordinates. You see, there's a coordinate up there, and then there's a coordinate all the way down here. That is one thing that we know for sure. Now, the one thing with what you call, with analytical geometry, is that your questions always stack on each other. So if you look at the previous question, we got the equation of Jn. Now, I don't think that's a coincidence, because if you look nicely, the equation of Jn meets the straight line NL here. These were these two lines meet. So we know that if they're asking us what's the furthest it can go upwards, we just need to find out first what is this coordinate there. If we can find out that coordinate up there, then it's going to be easier for us to answer our question, because whatever we are going to do, even if maybe we don't understand the question nicely, as long as we know what the point N is, we're good. Because our question clearly is talking about us moving the circle here up or down, or it's talking about us moving this circle along the line NL, and we just showed how if it's moving all the way up, it can only go all the way until there. If it's moving all the way down, it can only go down until there. But anyways, let's find N. So to find N, we need to find the point where N is, of which we can just find the point of intersection of Jn and NL. So let's get the equation of NL. So getting the equation of NL, looks like we're gonna use this good old equation of a straight line formula. The gradient of NL, we know that we can get it from Fj. It's just -3/4. So let's see here. Gradient is -3/4, right? That's the gradient of NL, which is the gradient of Fj, because they're parallel lines. Yep, no, it's -4/3, bruh. Eee. Yeah, the mistakes are getting too many, bruh. Come on. Come on, focus. So the x value that the line passes through, we have m, so we can have the, what can we have? X minus x1, which is like 14, and y minus y1, which is like what? The whole 100 and what? The whole square root. You have to be careful. If you don't put your answer under inside brackets here, it's gonna be wrong. So here, let's just do it slowly, right? Multiply inside there, and then that's like positive 14. No, -4. -4/3 times -14, right? That's gonna be like 56/3. This and this is this, this and this is this, right? And then here we have y minus square root of 1/4 minus 2. Okay, fine. Now you can just move everything on the right. So this is like -4/3x plus 56/3. This whole thing goes to the right. So square root of 4, And then now we can just put the numbers in the calculator. You see -4/3x. This whole thing in the calculator, let's see what it gives us. 56/3 plus that whole number in the square root. What is this thing now? Yo. It doesn't look pretty at all. It doesn't look pretty at all. We might as well just write this, yeah. Let's not, yeah, it doesn't look like we can do much really. We might as well just write these together and leave the whole square root of 1/4 on its own, because in our calculator, the answer we were getting is not very nice to look at. But who cares? Let's just write it out. So this all put together in the calculator, it's giving us 50 plus 6 square root of 26, the whole thing over 3. I mean, like, that's what the calculator is giving us. So hey, we can't fight it, So this is the equation of NL. We want to work out N, which is the point where Jn and NL meet. So here, therefore, in the equation of Jn, where is Jn? What's the equation of Jn? We worked it out here. So the only annoying thing, or not only, one of the annoying things with this question paper is that with these answers here, you can see it's all dealing with fractions. And yeah, sometimes we just don't like fractions because we're always like, something is wrong. But everything is fine here, actually, funny enough, because so far I don't think we made any dumb mistakes, because life is good. LG, we're LGing it right now. So let's see. There's a plus 50s, and also this whole square root thing is, yeah, it's kind of creepy. Everything on one side, what you're gonna get? You're gonna get 3/4x plus 4/3x. Then this on the other side is like 50 plus 6 square root of 26. Then you're gonna have minus 33/4. All this in the calculator. Let's see what you get. Let's see. Oh no, everything is fine, bro. Come on, relax. Relax, Brody. Relax. You is doing okay. You is doing okay. So 25 over 12 there with the x. These numbers put together, what you're gonna get? 50 plus 6 square root of 26, and then a 3 there, minus 33 over 4. And what you get? It's like 18.61. Okay, fantastic, right? You're gonna divide both sides by your numbers. So it's like 25x with the 12 there. That you can just divide it by 25 over 12. And then here, you also just want to divide it by 25 over 12. So this is where things you can see they're getting like, yo, it's madness, hey? It's like pure madness, because it's like, bruh. Because like, bruh, you know, like, bruh. But you gotta do what you gotta do, you know? So the answer here in the calculator, divided by the 25 over 12, because in the calculator, I didn't like remove the answer. It's like, this is gonna give us 8.94. What a wow. What a wow. What a wow. This question is quite crazy, but having to have done it, it's not so bad really, because I'm like the highest that the line can, what you call, or rather the lowest x value is technically going to be this, because if you move it upwards there, then wherever it's touching here, that's going to be the lowest x value possible along the line NL. Because if you move it towards this other side here, right, the highest x value where this line would be between your tangents would be whatever this x value is over there. So yeah, this question is quite strange. Let's not lie. It is strange, it is weird, and it's not fun at all. But hey, we're done now, so let's move on. Question number 5. We have something quite interesting to deal with. No, not really. Interesting, but what are you saying? But this is like straightforward questions. It says in the diagram, K, P is this, right? So you have point P there. It is a point in the second quadrant, and it is 10 square root of 10 units from the origin. Okay, so automatically we can already put a line here. It's standard procedure, you know. So K here is obviously a negative number. That we should know. However, this is just K units because distance cannot be a negative. And then X value, Y values are 1, so this is like 1 unit upwards. Okay, it's fine, it's fine. So they say calculate the value of K. So we can just use Pythagoras, because square root of 10 squared is equal to 1 squared plus K squared. Now it says here, K squared is here, right? This is going to give you a 10 because the square root cancels the square. Minus 1 here. This squared, K squared. 10 minus 1 is like 9. And then you have square root of 9, square root of that. That's going to be like K here, square root of 3. But the issue is, you see, you have to put plus or minus here. So here, therefore, K is equal to minus 3. You see, because K is on the left side of your Cartesian plane. So this coordinate of P is like negative 3 and 1. So you can already put here negative 3, you see. We just said if you're going to take a distance, you just have to take a 3. So for 1 mark, without using the calculator, calculate the value of negative cos theta. Now, the one thing to just remember is, as long as this is theta, right, always look at this as theta also. It's just weird, strange, funny, dumb, but it is what it is. So if you're getting cos theta, it's like negative, it's going to be adjacent over hypotenuse. So you have the negative in there, and then cos theta is like adjacent over hypotenuse. It's like adjacent over hypotenuse, which is obviously just that. So you keep on moving forward. Don't even overthink it. They want us to get this expression. So you might as well simplify it first, because you see things like sine 180 plus theta. You can, it's on your answer sheet, like show that you're simplifying first, because you don't have to just jump into the question they've given you. So this, we know, according to the cast diagram, let's see, CAST. according to the class diagram, 180 plus, you're going to have here 180 plus, right? Which is going to give you sine theta. And then 360 minus 360 degrees minus a reference angle. If you're dealing with sine, let's see here, sine 360 degrees minus, clearly in this quadrant, sine is a negative, so you're going to have your sine theta. So here now you can say, therefore, in the expression that you're given, you have the 1 minus sine theta, and then multiplied by negative sine theta. Don't make the mistake of not having the brackets, because if you don't have the brackets, that's when you start to flop. So what is sine theta? Sine theta is just opposite over hypotenuse. You see 1 over square root of 10. So this is going to be 1 over square root of 10 multiplied by negative 1 over square root of 10, of which you're multiplying. So remember these two BODMAS, you see, BODMAS rules. So here, this times itself with a negative there, you're going to have 1 times 1 there, which is a 1. Or rather, let's put brackets. 1 times 1 is a 1. Square root of 10 times negative square root of 10. It's going to give you a negative 10, like that. Very nice, very nice. And the negative times the negative is going to give you a plus. So this is what you have, which is like square root of 11 over 10. Whew. Okay, everything seems to be going all nice and all dandy until now. Because I'm like, bro, just double check your answers. Everything looks nice. Oh, no, this is supposed to be a negative. What do I do here? Ish. That is the way I don't like it now. Ish. Hey. Oh, man, I made a mistake. 180 plus. This is supposed to be a minus, bruh. Hey. Good Lord, have mercy. Have mercy on my soul. There's a negative. So this times this is going to give you a plus down there, actually. Meaning you're actually going to be subtracting here. Meaning here you're actually going to have 9 over 10 as your final. Yeah, square root of 9 over 10. Whew, yeah, ne? The way silly mistakes just happen, it's like, bruh, come on. I literally just said in this quadrant sign, I don't even know what I said, but whatever I wrote and what I wrote here, not the same. So sorry. The boy was just in the zone, in the wrong zone, clearly. Let's see here. The way this is set up, I'm already thinking of compound angles, like legit. Because I mean, like you have sine with something plus, sine with something. No. Yeah, I'm already thinking of compound angles. The reason I'm thinking of compound angles is because, just look. Sine theta over 2, cos theta over 2, with like minus the 15 minus 15. But the other thing is, even if we do compound angles here, it doesn't look like we are going to get anywhere. Yeah, it doesn't look like we're gonna get anywhere. That's the honest truth. Okay, yeah, so I'm looking at this question and it doesn't look very straightforward, to be honest. It kind of looks a bit strange. The reason why I'm saying it looks a bit strange is because it just does. It really just does look strange, bruh. Come on. Let us be honest with each other. This question does look strange. It doesn't look pretty. It doesn't look fun. It just looks annoying. And my question is, where would a person even start with this kind of a question? You'd be thinking to yourself, where would a person even start? So in terms of like where to start, right? This is where you really need to be creative. Because anytime you deal with half angles, right, always think of double angles. You see, think of double angles. Now, when I say think of double angles, the only thing that is making sense here is if you think of your double angles, the only double angle we have that has sine and cos pasted next to each other is this one, sine x, cos x with a 2 in front. So in our equation here, right, we can see that there is technically like a 1 in front here. So as long as there's a 1 in front here, we don't exactly have this whole structure, you see, because we have a 1 in front here, and then we have sine with something, cos with something. It doesn't fit this way of thinking, you see. So what you can do for yourself is thinking of this compound angle, or think of this double angle expression. What you can do is, if you divide both sides by 2, divide this side by 2, divide this side by 2, what you're going to have is sine x cos x. This is technically equal to sine 2x the whole thing over 2. This is how we could be thinking, you know. So what you can do for yourself is, you see here, sine 2x over 2 is equal to sine x times cos x. So in our situation, right, what we can already see is that as long as there's a 1 in front there, right, it is equal to sine 2x over 2. Now the good news is, in our expression, right, it looks as though these two big brackets here, this bracket here, let me color code it, let me put green. Let's use that bright green, man, the neon green. So you see here, whatever is in here, it's being represented by whatever would go there, you see. So here we can say, whatever these brackets are, it's where x would go, you see. So here we can say, therefore, sine with the 2 multiplied by these brackets, so it's like a half over 2 minus 15. And then here you have the whole thing over 2, right? Then you have like sine, and then you have like theta over 2 here, minus 15, cos theta over 2 here, minus 15. And then here we have to be thinking creative. So remember, this is just the whole angle of sine, right? So here on the left you have sine. So you now know that whatever you're given here, right, it's whatever this is, you see. So instead of you like working with this thing here, you can just now work with this side, you see, the left hand side. So on the left hand side, we have sine here, 2 times your angle there, it's like 2 theta over 2, and then like 2 times the 15 is a 30, the whole thing over 2. And then here you have like sine theta minus 30, the whole thing over 2. Now theta minus 30, I mean, now you can do your whole compound angle stuff, you see. So with compound angles, you know that an angle minus an angle there, you can just say sine theta times cos 30. Since there's a minus here, this is going to be a minus. Then you have like, no, sine 30 again. I mean, sine 30 here, and then cos theta, you see. This is still over 2. Of which now, remember this whole question here is 5.1.3, meaning we can still use our sketch, of which sine theta is like adjacent, I mean opposite of hypotenuse, cos theta is adjacent of hypotenuse. So we have those values since we need them, you see. So sine theta is like 1 over square root of 10. Cos theta, we can just use our special triangles. According to our special triangles, this is 30, then there's 1, 2, square root of 3, there's 60 there. Sine theta, I mean cos theta is adjacent of hypotenuse, so it's like square root of 3 over 2. Cos theta is like 1 over 2, so it's like a half. Cos theta, according to our sketch, is like what? Adjacent of hypotenuse, so it's like negative 3 over square root of 10. Negative 3 over square root of 10. The whole thing is being divided by 2. So they say without using a calculator, but they just mean, all that means is just show your steps, like legit. But what it also just means is just do it bit by bit, you know. So what you can do for yourself is in your calculator, just put these two. Well, you don't have to use your calculator actually, because it's 1 times 1 there, it's like square root of 3. Then this times 2 is like 2 square root of 10, right? 1 times that is going to be like negative 3. 2 times this is like 2 square root of 10. Remember, the whole thing here is being divided by 2. So what do we have next? So these are the bases are already the same. The denominator is the same, right? So we can just work with the top. Square root of 3. This is going to be a plus. And then what? Come on now. This whole thing here is being divided by 2, right? So remember, you dividing by 2, I mean, you can just tip and multiply. So this is just times a half. Because the 1 is over, the 2 is over 1, right? So you can just flip it over. And then now you're multiplying. So this is a square root of 3 plus 3 over 2 square root of 10. So 1 times the top. Yo, why am I writing skew like this? Yeah, I don't know. And this times the 2 is going to be 4 square root of 10. Whew, is that what we have here? Nice, 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 nice. Nice. Let me just try and straighten this thing here because it's like, bro, what in the world, man? Like, it's beyond repair, this one. It is what it is, but you can easily see what is going on here. So moving on to the next question for 2 marks. They said sine theta plus 60 is equal to d, right? Write down the values of d such that sine theta plus 60 is defined. Hi, Bowman. Hi, Bowman. Why do you have to be so weird about it? You know? Why do you have to be so weird? Because honestly speaking, this question, it's straightforward, but at the same time, it's not. Because as I'm looking at it, I'm like, wait, what? Like, what? Yeah. What? Oh, wait a minute. This is just a sine graph. It's a sine graph that has been shifted 60 degrees to the left. And this is technically representing the y values that this graph goes to. Because remember, as long as you're throwing in values for theta, you're going to be getting y values. Now, this equation, I mean, like on a Cartesian plane, all it looks like is instead of passing the origin at 0, it's going to be passing the origin at negative 60. And then it's going to look something like this, you see, until like positive 300. In the middle here, it's going to be like 120 because everything was moved 60 to the left. Now, your graph still has an amplitude of 1. So your graph still goes all the way to positive 1. No. This is not, somewhere up there will be the 1, right? Because the turning point is like somewhere there. So somewhere there is a 1, somewhere down there is a negative 1. So here, we'll have to say that the range is your y is an element of 1 until negative 1. No. Bro, 1 until 1, you see. Of which d here is representing the y value. So here, therefore, d is element of negative 1 until 1. And that's the way we are like it. 5 marks. If d is this, okay, plus the square root of 3 over 8. Yeah, they probably did some whole compound angle stuff here and got this here. They said here, if d is this, the general solution of, if d is equal to this plus this, the general solution of this is equal to d is theta is equal to plus or minus m plus n plus 360. Calculate without the use of a calculator the value of m. So I feel like we should just get the general solution. Like, I don't even know why we are busy here doing dumb things. Or are we? Yeah, d is equal to this. The general solution of this is theta is equal to blah, 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 blah. Yeah, this is where things are like, these are things get a bit weird because it's like, okay, what do they actually want us to do? They want us to get the general solution. But quite frankly, the question is not straightforward. But it kind of is straightforward, maybe not. But let's just see what we can do. So here it says that sine theta plus 60, without overthinking it, they said it is equal to d. But then they gave us d as this value. So let's just throw it in there. Sine theta cos 60 plus square root of 3 over 8. Okay. On the left, we said we can do some whole double angle stuff. So sine with a plus, you're going to have here sine the angle and then cos 60. Then you're going to have plus sine 60 and then cos theta. This is equal to sine theta cos 60 plus square root of 3 over 8. That's what they gave us. So it looks like two things are going to cancel out because this and this look exactly the same. So if you take it on one side, you're going to have here sine 60 cos theta equal to square root of 3 over 8. Okay, fine. So it looks like for us to get any kind of general solution going, we have to get the cos sine 60 there. The sine 60, we know it is equal to opposite over hypotenuse. So it's like square root of 3 over 2 cos theta equal to square root of 3 over 8. So therefore here, cos theta is going to be equal to this divided by that. Whew, weird. But what we are seeing is what we have to do. So we can just flip this over, right? So it's like 3 over that times 2 square root of 3. Yeah, this is looking all weird, like it really is. But the fortunate thing is anything under a square root, right? You can write it as the square root with the number on top, the square root with the number at the bottom. So this is going to be 2 square root of 3. This times this. Remember, two numbers being multiplied together. As long as they are both under square roots, then you can just multiply the insides. 8 times the 3 is like 24. So square root of 24 is like down there. Yep, that is the way we like it. Is it? I don't know, maybe. Is it? Yeah, it kind of feels a bit strange, but I feel like I should just pause on this answer here and look at it nicely and be like, bruh, did you just write out what I think you wrote out? In my head, I'm like, I don't know, bro. I don't know. I'm just like, yeah, I feel like I should pause here because it seems like I'm doing a lot of things in my head, but I just want to verify with the calculator. Because if they say don't use your calculator, they just mean show your steps, you know? So in terms of like verifying your answers and all that, I'm like, feel free to, you know, to verify and stuff. But let's see. It's looking all interesting, this question. But anyways, yeah, everything seems fine. The only issue is if you're not going to use your calculator, you need to at least have something simpler here. So yeah, this is where things get a bit crazy. But let's see. No. This is not a good idea. We can actually just say 1 square root of 3 cancels the one down here. Then you have 2 square root of 8 down here. But the issue is here you also cannot like use this without using a calculator. So you need to be creative, right? So 8, you have to write it in terms of square numbers. So it's just like 4 times 2 is the only way you can write the bottom. 4 times 2, which is then gonna give you square root of 2 and square root of 4, right? So it's like 2 here, square root of 4 times square root of 2. You're gonna have 2 at the top and then 2 square root of 2. And then the 2's cancel out. And then you have 1 over square root of 2. This is what cos theta is equal to. Okay, what's the question? Wow. So we have cos theta now, so we can just get the general solution here. The reason why this is doable now is because if you think of your 45-45 triangle, 45 and 45, we have 1 square root of 2 there, right? Of which we know that theta is going to be shift cos 1 over this. So because we have our 45 triangle here, it's easy for us to say therefore theta is going to be equal to technically the whole shift cos business. I mean, like here the sad thing is here they put the a plus or minus m. Trust me, without fighting it, you can just put for yourself a plus and a minus 45 there. And then here you can say plus n 360 n is an element of integers. You know, the n is an element of integers part. I mean, like you can leave it out for now because that's not what our question has. Our question is just plainly just like that. So there you go, all nice and dandy. This question was quite interesting. It was it's not very straightforward because the whole not using a calculator thing, yeah, that can easily throw a person off, but it is what it is. For 3 marks, yeah, ne? For 3 marks, it's like, what is going on here? Yeah, this question is just crazy. If it says that it is given, yeah, let me actually pause and think because let me read it first. It is given that A is equal to this expression, right? Calculate the value of A. What? Well, what we know is remember, M is plus or minus 45. So we have to be careful there. It looks as though this question is just super, it looks weird. It really does look weird. Like, I don't align it. It does look weird. But then it doesn't matter. It doesn't matter. Because look, I feel like this is one of those trick questions. Because it doesn't matter what this is. Remember, all this is saying 2 to the power of a certain number, right? So we know that M is going to be plus or minus 45. So what do we know now? What do we know? So this is saying A, B, C, D all the way until X, right? So somewhere along the lines, in the middle here, you're gonna have M somewhere and then minus an M, you see. So somewhere along the lines, you're gonna have a sign M minus an M, you see, of which sign M minus M is equal to a 0 because sine 0 is 0, you see. So this would be sine 0, of which sine 0 is a 0. So it means that as long as you have anything times, as long as you have sine 0 somewhere, you're going to be saying 0 times everything. So it's still always going to be a 0. So here's 0. Let's just say this is going to be 0 times anything, right? It doesn't matter. It's still going to be a 0. So the final answer here is a 1. Whew. Yeah, this one was like, but yeah, I think, yeah, trick question. This is definitely a trick question. Trick question. And as weird as it looks, it is what it is. So moving on to question 6 now. What does question 6 say? Question 6 says, okay, we're dealing with a function, with a trigonometric function, I guess. It then says here, in the diagram below, the graphs of f and g are drawn in the interval negative 180 until positive 360. Okay, yeah, we can see it. Negative 180 until positive 360. So this looks like a standard sine graph, meaning in the middle here we have 180. Let's see the equations. Okay, we have not been given the equations, but this seems like it goes all the way to like positive 3. If you look at this, the equation they've given you, there's no shift from top to bottom here. So you can be certain that the highest value here is a 3, and it also then means the lowest value here is a negative 3. So that kind of information, you need to know it. The other thing is there's one graph in a space of 360. So it means that your A value is just a 1. No. Amplitude is the 3, as we have just said right now, from maximum value minus the minimum value divided by 2 always gives you the amplitude. Or rather, let me stop answering the questions before we even finish reading the questions, because yeah, we've been given f of x and g of x. They are drawn in the interval negative 180 to 360. Point P is this point. On the graph of f, the function h of x is a straight line. So remember, this is a straight line, right? And as long as this straight line has the equation y is equal to something, it means that its y-intercept there is this number, the 3/2, like that, you see. So we have to be careful, because that 3/2 is giving us this value here. Perfect. Now it then says here the graphs, the function h intersects the graphs of f and g. So there's f, where is f and g? There's f and g. And then it says the asymptote of g goes through one of the turning points. Okay, that's interesting. So this is like 270, remember, if you know your work. So the other issue is, you see, between 270, you would expect another asymptote at like 90, but you don't have it. So that's not a coincidence. So if you're looking nicely, you can already see that half a 10 graph is in a space of 270. So meaning you would see another full 10 graph this side, meaning that your other asymptote would be somewhere here at negative 270. That's just the dynamics of this image. And you want to take note of those kinds of things because we definitely need them. Then it says here A and B are coordinates. There's what? There's B here. Where is A? A is somewhere here where the points, where the graphs meet. And then they say these are points of intersection of the graphs of F and G. Now, the fortunate thing is they say we should write down the values of A and B. So you knowing what A and B is heavily hinged on your theory. If you don't know your theory, these questions are going to seem difficult. But with f of x, the one thing we already mentioned is that this is the equation you're given. A is always the amplitude, you see, of which your amplitude has a formula. It's the maximum y minus the minimum y over 2. So the maximum y value that your graph goes to is like a 3. The minimum is like a negative 3. You see, this is like 6 over 2, which is a 3. That's going to be your answer. Somebody is calling me. I have to pause. We are back. Where was I? Amplitude is a 3, right? Because of this formula. So A is a 3. That one is simple. With B, however, B is clearly the frequency of your 10 graph. Now, frequency of a 10 graph, you have a formula, right? Frequency is equal to, yo, bro, write it nicely, bro. No one is chasing you here, Brody. Frequency is equal to 180 over the period if you're dealing with a 10 graph. Now with the 10 graph, remember the period is how long it takes you to get a full image. Now it's taking you from negative 270 to positive 270 to get like a full 10 graph, you see. So the distance here is 270 plus 270. That's the period. So here your value of B is going to be 180 over 270 plus the 270 there, you see. So this is like 180 divided by 540, 20. Yo, Brody, my brain is like, nope, I don't want to work. I don't want to work at all. You have not fed me today. You only fed me once. I'm like, okay, fine, sharp. Refuse to work. But anyways, in the calculator, let's see what this value is. 180 divided by 540. Yo, bro. It's like 1 over 3. This kind of makes sense because this is saying that in a space of 180 degrees, you have 1/3 of a graph, which is what we're seeing in our image. So don't fight it. Just accept, just accept. So that's for A and B. The period of G, what is G? G is our 10 graph. Wow, guys, really? 3 marks, you see? The period here is just 540 because it's taking 540 degrees to get a full graph. So coordinates of A is the point of intersection. Now, you may be thinking to yourself, do you have to work it out algebraically? The good news is no, you really don't, because these points are symmetrical, you see. So use B. So you know that B is 154.69, coordinate 121.28. This is B. Now A is just a reflection of B, one way or the other, you see. Because this is like if the x value here is like 154, the x value is negative 154. That's one thing to remember. Negative 154.69 there. And then this one, if it's positive 1.28, this one is going to be negative 1.28. Negative 1.28. Perfect, right? Then you're good. So 2 here says write down the coordinates of A. Writing down the coordinates of A. Did I just do the same question twice? No, bro, you wrote it on the wrong thing. Come on. Oopsie. Whew, did I just say oopsie, bruh? My guy, just getting us, bruh. Oopsie, what is that? It is given that 210 this minus this is equal to t plus 5. Yeah, this looks weird. Calculate in terms of t the vertical distance of f and g at the point where h intersects g. Yeah, that's a weird looking question. We have to read it again. Given this expression, calculate in terms of t the vertical distance between f and g. Where is f and g? So there's f here, which is our sine graph. G here is our tan graph. The vertical distance between f and g at the point where h intersects g. Oh, where is h? H here intersects g over there. Now they want us to get the vertical distance between f and g at the point where h intersects g. So they want us to get this distance here. This distance here. From this point to that point. Now, before we can get the distance here, we need the x value there and its y value. Or technically, we just need the y values of the point up here and the point down there. So what's the mark allocation here? It's a 4-mark question. Yeah, I don't align it, but yeah, it looks like quite an interesting question, this one, because yeah, it doesn't look very straightforward, eh? Given that this minus this is equal to t plus 5, calculate in terms of t the vertical distance between f and g at the point where h meets g. So the first thing we can do for ourselves is to find out what is the x value where h is meeting g, because that's actually what matters. Because the vertical distance between f and g, it is just going to be, let's see which is on top here. G is on top, right? So the vertical distance, you're going to say the y value of g minus the y value of f, meaning it's going to look like the y value of g minus the y value of f, right? This is going to be a vertical distance. Vertical distance. So with your vertical distance, the issue is if you take the equation of g, what is the equation of g? It's like 10 1 over 3x. 10 1 over 3x minus 3. No. Yes, the amplitude is a 3 sine x, right? This is your vertical distance. So what we know is that whatever the vertical distance is, if you're gonna get the vertical distance in terms of t, I mean, like that's already something else that we what you may call, we don't necessarily need to worry too much about. The only thing we can worry about for now is what? Is come on, bro. Think. What can we do? Let's just get the x value where h meets g, because if you have a distance formula here, right, for you to get the actual distance, you just need the x value where these two are aligned. So to get that x value, what we know is, remember, h, the equation of h, the y value there is just 3 over 2. So in the equation of g, we can just put 3 over 2 first and see what happens. So in the equation of g, let us put 3 over 2. In the equation of g of x, we know that the y value is 3 over 2. So this is like what? 3 over 2, what you get is 3 over 2. 3 over 2 is what? 3 over 2 is equal to 10 a third. That's quite interesting. 10 a third. You have to get your reference angle and stuff like that here. But yeah, let's see here. Therefore, the reference angle is got to shift 10, 3 over 2. Shift 10, 3 over, yeah, 3 over 2. We're getting there 56.31. That's your reference angle. But then you're dealing with the positive numbers. So, cast diagram shanbies. So 180 plus. So 180 plus, bruh. Yeah, so it's going to be a third x is equal to 180 degrees plus your reference angle. So it's like what now? Yo, bro. So this is like 236.31. Yo, nah, this is kind of getting scary. It's kind of getting scary, bro. It's kind of getting scary, bro. But then the issue is, you're dealing with something before the 180. So, yo. Well, in the first quadrant, this doesn't look like it's going to give us a valuable answer, because this is going to be divided by a third on this side, divided by a third on this side. Yeah, it's not going to give us something pretty. That is definitely the case. So here, this one it doesn't work out. So we need to use the first quadrant. You see, the first quadrant will have, therefore, 1/3 x is equal to 56.31, which is going to give us x is equal to 56.31 divided by a third. X is equal to 168.93. Okay. That's the x value that we are getting, right? So if that's the x value that we are getting, we need to now see how that is useful to us. So we are seeing that the x value here, where we have the distance they're referring to, the x value there is like 168 point something, and that's accurate, 168 point whatever we are getting over there. However, doesn't end there. Let's see what our question looked like. 168 point. Okay, it looks like we have at least something there. Fine. And then 210, blah blah blah. So now we have to incorporate this question that they have given us, because yeah, it doesn't look good at all. It doesn't look real good at all. It doesn't look good at all, man. It really doesn't. Because it's like, but what next? What next, people? What next? Well, taking into consideration what we have, without sugarcoating it, this question is not looking pretty. But wait a minute, there's a 6 here, whereas in the equation of the oh, wait a minute, bro, everything is fine. Look, we wrote this formula, right? So we can just carry on from here, actually, because remember, our distance is just this. So fortunately, we have an x now, right? So remember, what we would have written out is just 10. A third times this number is just let's see in the calculator, third times that number. Oh, it's just going to give us the 56.31. Perfect. And then we are minusing 3 sine 168.93. This is equal to the distance. Distance. And I feel like, bro, you're not writing nicely, you're not writing clear, you're just doing your own nonsense here. Ish. Move this thing to the left a bit, so that we can show that this is just the distance. Distance. So what we can already see is that if this is our distance, I mean, like, how are we being helped now? Well, from here to there, it looks like everything was multiplied by 2. Yeah, it looks like everything was multiplied by 2. So if you multiply everything, so for us to get what we have in our sketch, because they say that it is given that this is equal to this, right? Calculate in terms of t, the vertical distance. So if this is our vertical distance and we need it in terms of t, what we can see that everything here is just multiplied by 2. You see, so this is going to be times 2. We're going to have here 210, 56.31, negative 6 sine 168.93 equal to 2 times the distance. But then d should be the subject of the formula. It doesn't matter. They said we should write the vertical distance in terms of t, of which this thing now, we know it is the same as t plus the 5. So the whole thing here becomes t plus 5 equal to 2d. But then d should be the subject of the formula. So this is going to be t plus 5 over 2. Yeah. No jokes. This question, or what is this? These questions are fire. When I say these questions are fire, I literally just mean, yeah, they are not playing games at all. They are not playing games at all. They are brutal, and yeah, the life we live is definitely a, yeah, it's just crazy. It really is just crazy. But let's do what we gotta do. Let's do what we gotta do, and let's see what we can come up with in the next question. So, question 7, here we are. So to be honest, yeah, this question paper, yeah, it's throwing hands, like serious hands. Prelims whip. So it says here in the diagram below, still pose AF. Where's AF? There's A and F here. There's BD, which they're saying it's Y, the distance there. And then you have CE. And then they say they're equal in length. Okay, so if this is Y, this is Y, and this is Y. They're equal in length and vertical to the horizontal plane. So this is like the flat ground, and these are poles going upwards. And then they said here, the still poles hold triangle A, B, C. So there's this still poles holding this triangle up there. It's almost like a roof, the foundation roof. And then it says, yeah, it is the still poles hold triangle ABC that forms the roof of the storage area. Okay. And then it says G is the midpoint of DE. Okay. And then it says BCDE. BCDE is the same vertical plane. So this is like a flat surface here. It's going upwards. Then they said AB is equal to AC. So there's like AB here equal to AC. That's why they labeled those X there. And then they said here, with AB equal to AC, right? They're both equal to X. Then they said BD is Y. Then they said BAC is equal to theta. Okay, that's nice. Oh, nice and dandy, I guess. Why did I give myself? Oh, I gave myself enough space. So for 3 marks, they want us to show that BC is equal to this. So without even worrying about what they're asking us to show, right? The first thing you can just do is to focus on where BC is first, and then worry about what they're trying to have you show later. Because if this is BC, the idea is you want to focus on which triangle can help you get BC. The only triangle that can help you is this one. The one here. There is angle theta up there, where A is. There is B here. There's C here, right? Now there's X and X here. So this is kind of straightforward because it looks like we're going to use the cosine rule here. Because the cosine rule clearly states that a side squared is equal to the other two sides squared plus each other minus 2BC cos the angle. You see. So as long as you know that this angle goes with this angle goes with this side, you're good to go. It's going to be this side here and this angle. These two go together. They are the ones that go on the edges. So meaning here you have BC squared, right? It is equal to AB squared plus AC squared minus 2AB AC and then cos the angle. So with all that being said, right? BC is what? We don't know. That's what we're trying to work out, bro. So AB though is like X. So this is like X squared plus X squared minus 2XX. So that's going to be X squared, bro. Should have just put an X squared there, but no. Somebody wants to be extra. Or do I? Nope. Well, so far so good. Everything looks all nice and dandy. But don't do the mistake of canceling these two because you see this one is going with the cos theta. So you can take it out as a common factor though, you know, just for the vibes, you know, because why not, man? Why not? Oops. No. Don't get carried away, bruh. So from here, you can square root both sides now. Meaning you're going to have square root of this, square root of this whole thing here. So here you're going to get BC. Oh, let's now start to see. Okay, yeah, we have. So here I think we can pause a bit, because if you're going to end up with X only as the outside value there, no, it's fine. Everything is fine, because here you see these are being multiplied together. So here you technically have square root of 2x squared multiplied by square root of what you may call the 1 cos 2x. Or rather, putting it like this, it doesn't look like it's going to make sense. Let's put the 2, and anything that's not a square number, right? It's pointless like trying to square root it. So we can just keep these under the square root symbol, because they're not going to change anyways. But then for the one with the squared here, this cancels that. And then you have 2, 1 minus cos theta. Ooh, let me go and close the door because somebody's mowing their lawn. Oh no. The door is closed. It's the window. Or the windows. And I'm thinking to myself, bro, you could have just like paused and then close the windows, but no, you had to close the windows while you're still recording. For 1 mark, let's see. Write down the size of BDG. Whew, what is BDG? I don't know, hey. BDG is what it is. So the size of BDG for 1 mark, right? 1 mark, they want the size of BDG. So let us be careful. Where is BDG? BDG. Well, it's a 90-degree angle, bruh. Because this is a pole going upwards. This is the ground. So remember, all poles always meet the ground at an angle of 90 degrees. That's just logic. That's a 1 mark question. For 3 marks here, it says show that BG is equal to this whole thing here. So the same way we worked at BC is how we want to work out BG. Don't focus too much on BG. Otherwise, you're going to not have a good life. So let's see here. BG, the way it is, meh. The fortunate thing is, remember, BC is the same as DE. So whatever we got for BC, we can just cut it in half. And we will have like DG. Is because this is half, and then BC is the same as like DE. So let's see what we can do. This question does not seem like it's going to be difficult at all, because we have a right angled triangle here. There's like DG here. There's like BG there. This is Y. This we know it's going to be, let's see here, DG is equal to half of BC. That we know. So therefore, half of BC is going to be half of this. So it's like a half x square root of 1 minus cos. How theta. Yeah. Oh, looking nice. I'm just, the 2. I forgot the 2. Yeah, when everything is going all nice, that's when you make a dumb mistake. But let's see here. This thing here, we have to multiply it by a half. No, by a half. It's a half of BC. So let's see here. Take this out. This is like a half. Yeah, a half x. A half x. I don't even know I'm rewriting it again. It's just weird, but hi. And I'm wasting so much space because I'm like, bro, you took the whole thing just to write this out. So let me just shrink this all the way, move it in the corner somewhere there. So now what? So we have this, we have this. Oh, Pythagoras theorem. Yeah. So don't be afraid of Pythagoras theorem, especially when things look crazy. So this is just going to be BG squared is going to be equal to what? BD squared plus or what squared? Plus DG squared. Of which here BG, DB is what? DB is Y. So this is like Y squared plus this whole thing squared. So it's like a half X square root of this whole thing. This is where your algebra is like tested, because gotta know what you're doing. So this is, everything is going to be squared, right? The half is going to be squared. It's going to give you a quarter. X is going to be squared, which is x squared. And then remember, this thing is also going to be squared, because in terms of like knowing what is going to be squared, right? Remember, this is being times by this, and it's being times by the whole thing under the square root. you see. So that's why here it's half squared, x squared, and then the whole thing here squared, which is going to give you the square is going to cancel the square root. So you're going to have here 2, 1 minus cos theta, like that. Really? I feel like something is looking a bit wrong here. Oh no, it's fine. We just didn't multiply the 2 inside. We just kept it out all the way. But it looks like now we can just multiply it back inside because, yeah, I'm forgetting the square there. So I'll keep that for now. So let's see how far we can go in terms of simplifying here. There's a quarter times x. So this is over 1. This is technically over 1. So you're going to have here x squared multiplied by this. You can multiply inside and have 2 multiply inside. But you see here, there's no multiplying inside there. So we might as well leave it out. Zoopoo. So what you gonna get? What you know about rolling down in the deep? Blah 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 blah. Oh. Oh no. Oh no. Oh no 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 no. I was flowing until now. Because now I'm like, wait, what? I feel like I just messed up, bro. I feel like I just messed up real good. Okay, not real good. I think I messed up maybe like slightly because it's like everything looked all nice. And then now we're like, wait, what? What's going on? Like, wait, what? You know? So, yeah. But I think we're good. Like legit. I really shouldn't be panicking right now. Like everything we've done is 100% legal, you know? So let's just see here. Let's just carry on, you know? Let me not panic. Like, calm down, bro. Calm down. Have self-respect, you know? So what now? What now? Right now, it's not looking nice. It's not looking nice. But the good news is, whoa, we're good. We're really good because look, we don't have to have these brackets here. We just have to keep in mind that this is being times by the 2, being times by this bracket here. Now the fortunate thing is the 2 at the top can cancel the 4. Like 2 here and the 4 down there, they don't cancel each other out. It's just 2 over 4 is a half. So you're going to have here x squared and then 1 minus cos theta. And the bottom here, you're going to have a 2. Nice. Okay, where are we going next? I don't know, bro. Oh, we can just get an LCD, actually. Reason is, you see here, our equation here has 1 denominator. So getting an LCD, it means that this is going to times by 2 and 2. So you're going to have 2y squared. And then x squared here. 1 minus cos theta. The whole thing over 2. Are we close? Are we close? Oh, we're literally one step away because remember the whole thing here is just bg squared. So we can actually now just square root both sides. Therefore, bg, if you square root it, it's going to be on its own. Then we have this whole square root thing here. 2y squared plus x squared 1 minus cos theta over 2. How many marks? 3. Sure. Okay. Okay, it's fine. It's fine. We will cry about it later, but for now, we have to carry on and just get the marks because we have no choice, ladies and gentlemen. We have no choice but to move on. 7.4, it is given that y is equal to 8 over 3 meters and x is equal to this. Calculate the maximum length of BG. So if they're saying the maximum length of BG, yeah, this is where it's like, wait, what do you even mean? So this is where the whole cos thing here comes into play because remember with cos theta, right, is a graph that will look like this. Zoop. Now, if you look at it nicely, the highest value it goes to is like what you may call a 1. The lowest value it goes to is like a -1. Now, the thing is, looking at what we have, right? Yeah, we kind of have to be creative. You see, we kind of have to be creative because in as much as this is a cos graph, what we're dealing with is 1 minus cos theta, you see, meaning we technically have an equation that looks like cos theta minus 1. No. Negative cos plus 1. If you swap these two around, this is what you'll be seeing. of which if you're seeing anything like this is like a course graph that has been flipped over. Apart from being flipped over, right, it was then moved 1 unit upwards, meaning your image, instead of going from like -1 to like +1, yo bro, what are you doing? What are you doing? Instead of going from +1 to like -1, this was moved 1 unit upwards. So your sketch would now look like that, you see, meaning the highest value it would go to is like a +2. So here when they're saying calculate the maximum length of BG, what you know is this thing here, the highest it can ever be is just a 2. So here you're going to have, therefore, BG is going to be square root of 2. Our y value, they gave it to us as 8/3. Our x value, they gave it to us as 15/2. And then our cos, our 1 minus cos theta, the highest it can ever be is like a 2. And then all that you can put it in the calculator. Woo, yeah, nah. Fire paper, this one. Let me see. In the calculator, getting a weird answer, but it's like square root of 2281, the whole thing over 36 to 2 decimal places. What you're getting there, we're getting like a 7.96. What a wow, bro. Like, what a wow. Just fire everywhere. Like, legit. Just flames. Like, is bad, but it is what it is. Anyways, let's move on to question 8. Question number 8. First Euclidean geometry question. Okay, it looks interesting, right? It says here in the diagram, O is the center. So we have O over there. It's the center of the circle with the radius OC. Where's OC? Oh, there. Wow, okay. We might as well highlight that because we might forget it later on, you know? And it's not straight, so it's like, bro, come on. Like, come on, bro. Like, let's just maybe do this then. And finesse it. Let's finesse it nicely. See? You see? Nice. So that is the radius, okay. And then it says ABCD is a parallelogram. Oh, if it's a parallelogram, it means don't take that for granted. But that's important. They said here A, B, C, D is a parallelogram. So automatically you should remember things like opposite angles add up to 180. So this is a tiny 20, right? It means that the other part here is a 10. The reason is because 150 plus a 30 has to give you 180 because opposite angles of a cyclic quad add up to 180. Then it says your n is another point on the circle. N is another point on the circle such that ON is parallel to BC. Oh, okay, that's gonna definitely come in handy. Like definitely, bro. Then it says your chord DN. Where's DN? Chord DN is drawn, and then it says OE intersects, or OE bisects the chord BC. So there's a law that says this is going to be bisected at an angle of 90 degrees, like it's a law, you know? And then it says your GC. Where's GC? Yeah, this one. Yeah, this sketch. To be honest, this is one of those sketches that look difficult, but to be honest, this one kind of looks like it is just a lot of information. And that information is really going to help us, like gang. So let's see. ON and OC. Where's ON? ON and OC, that's the radius. They're produced to meet, one of them is produced to meet F. Wow. And then it says this is 20, this is 150. Whew, there's a lot going on. There's 10 chord theorem, blah, blah, blah. Yeah, you see like this angle here is equal to that one because of the 10 chord theorem. This angle is equal to that one because of the 10 chord theorem also. Like, don't sleep on those theorems. For 1 mark, they said calculate with the reason, the size of O1. So already here, they spoke about parallel lines. So automatically you want to be thinking of alternating angles. And it just literally flew in my head how this is going to be equal to that, because alternating angles. O1 is going to be equal to C3, which is 20. The reason is alternating angles. Okay, So as long as you have that as 20, might as well put it down there, you know. Now the other thing is what? These are alternate, these are parallel lines, right? So it means that if this is 20, this has to be like 70, because this has to be a 90-degree also. So whether that's useful, I don't know, but maybe, probably it is. They want us to get D1. D1, where is D1? D1 is like there, this tiny angle here. So D1 looks quite interesting. I'm looking at where D1 is going, you see. I wanted to see if there's any other angle that is subtended by D1. And yes, O1 is also, I mean, any other angle also subtended by like NC. If you look at where N and C is, right, O1 is also going to NC. D1 is also going to NC. So what it means is O1 is double the D1, because an angle at the center is double the angle at the circumference. You see, this is equal to half of O1. The reason is angle at center of circle. You see, this is where DRCPT comes in, Dr. Cape Town, you know. Look at diameters, radiuses, you know, cyclic quads, parallel lines, tangents, all those things help you. Of which anytime you have a diameter or a radius, it should allow you to remember the center. And anytime you think of the center, think of theorems that you find at the center of a circle. So moving on, they want us to get C2, right? Where is C2? C2 is over here. Oh, we worked that out to be a 10, remember? What was the reason again? Oh yeah, opposite angles of a cyclic quadrilateral. So here we can say A plus C1 and C2. A plus C1 plus C2, this is equal to 180. The reason is opposite angles of a cyclic quad. So that being said, we know that therefore A, if you put angles in here, right, A is what? A is 150. So this is going to be therefore 150 plus C1. What is C1? C1 is like, no. Did I write C1? No, bro. It's C3 and C2. Yes, like, bruh. Yes, like. I meant C2 and C3. C2 is what we're looking for. C3 we do have. They gave it to us as 20. So this is like nice. Then there's like 180 here, right? So this is going to be C2 is equal to 180 minus 170. This is giving us a 10. 10 degrees. 10 degrees is our answer. Okay, those are very easy maths. And you can see how we're cruising with these questions. We are not playing any games. So here we have 10, we have 20. We got D1. What is D1 again? D1, we got it to be 10 as well. So funny enough, Ned, this is where things get really interesting. We can already see that DN is parallel to OC, because these are alternating angles. They're alternating angles that are equal to each other. So as long as these alternating angles are equal to each other, it means that DN is parallel to OC. That's just an interesting fact, I guess. So it means that this angle is equal to 20 if we ever need it, but we don't. What do we need? We need D2. D2, what we saw is that, or what we know from what we mentioned in the beginning, is that it's an angle up here, right? We know that it is equal to this angle here because of the 10 chord theorem, because you have a triangle in here, and this triangle, it meets a tangent here, and the angle with the tangent is equal to the angle that will be on this side. It's because there's a chord and a tangent. They call it the 10 chord theorem because your tangent and your chord, wherever they meet, that angle is always going to be equal to the angle opposite your chord. You see, so all that being said, we could get C4. Looks like getting C4 is going to help. And the other thing that I just spotted right now is that this whole angle here is a 90-degree angle, because there's a tangent perpendicular to a radius. So C4 and C3 together. So C3, C3 plus C4 is equal to 90 degrees. The reason is tangent perpendicular radius. Ka-ching. Oh no, come on. Come on, man. Radius. Now, what do we know about C4? C4, we have it, right? C4, What is C4? No, dude, we don't have C4, bruh. We have C3. We actually have C4 here, but never mind. C3 is like 20, 20. So it's like 20. Wait, where's the 70? Oh, bugger. Don't get confused here. Yeah, that's kind of some deep stuff. 20 here plus C4 is equal to 90. Then C4 here is equal to 90 minus 20, which is 70. Wow, man. So here, therefore, D2 is equal to what? D2 is equal to C4, right? Because of the 10 chord theorem. C4, the reason is 10 chord theorem. Well, after doing that, you know that therefore D2 is equal to 70 as well. 70 degrees, and you can move on because life is good. They said here, if it is given what? If it is given blah, 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 blah. Okay. It's all good. If it is given, wait, what did we do in the previous questions here? Okay, everything looks so nice and fine. If it is given that, what did they give us? If it is given that OF is this. So it looks like this is a totally different question, but I hope, are we still using the same sketch? Because they're talking about OF here. I think we might as well get the sketch because, yeah, I do kind of have the feeling we're still using the same sketch. Maybe not, but like, why would we not be using the same sketch though? Like, you know, just weird. So let me crop this out. Because the description, what? Because the description we did is it's, let's see up here, move this thing up there, make it bigger. Perfect. So they say here, if it is given that OF, where is OF? OF, where is OF? There's O here, F down there. This is 3y. Okay. EC, where is EC? There is EC there. It is 2x. The area of OECF is given by this. Okay, well, this is a trapezium, you know. It's a trapezium with a 90-degree angle there. So, okay, that's interesting. Determine the length of OE. So the fortunate thing is, if you know the area of a trapezium, like the formula, you're safe, because the area is always a half multiplied by the sum of the parallel lines, multiplied by the distance apart. This is one formula I have mentioned quite a few times already, whenever I could. So that's the area of your trapezium here. It's like the formula of the area of a trapezium. It's always going to be the sum of the parallel lines multiplied by the distance apart. So what you know is OF is one side, EC is the other side. So that gives us one side of the parallel line and then the other side. The distance apart is OE. That's actually what they're looking for, because you look at area is equal to a half. The parallel sides, the parallel lines, it's OF. The distance of OF, they gave it to us. It's square root of 3 with a y here, plus the other parallel line, because sum of parallel lines mean you have to add them up, right? So let me just maybe write it with symbols first. It's going to be a half with OF plus EC multiplied by the distance apart, which is OE, right? That's the distance apart. So as long as that's the distance apart, we're good. I'm getting a call, so let me pause this. Okay, let us carry on. So with all these, like, we have information for that. This is like a half. OF, they gave it to us for a reason, square root of 3y. So you can see why it is important for you to be versatile. Otherwise, this is the kind of a question that would have like tripped you all the way up. But yeah, in good hands, so do not worry. They want OE now, you see. They've given us the area here. It is 3 over 4y. I keep scrolling up and down. It's even annoying me. I'm like, bruh. Let's see. A half times this is going to be square root of 3 over 2y And then a half times 2 is going to be a 1. So this just that. We need to make OE the subject of the formula, right? So we have to be careful here. But it doesn't look like there's something crazy really here. We just have to divide both sides by this. So here, therefore, OE, if you divide both sides by what's in front, you're going to have 3 over 4y here minus x squared, the whole thing over. Square root of 3 over 2y plus x. That's OE. So whether you're going to like simplify it further or not, I guess you should, because likely this is just, it looks like the difference of 2 squares here. Because look, square root of 3 is square root of 3. Square root of 4 is a 2. Square root of y squared is a y. Square root of x squared is a x. So here at the top you can factorize. So here, therefore, OE, the top here you can just say square root of 3 over 2 plus no, with the x here, bro. X there. And then here square root of 3 over 2 as well, with the minus though. Come on. Come on. I'm busy writing. I don't know why I'm rushing to be honest. And then the bottom here you have square root of 3 over 2 y plus the x there. And then this will cancel out. Ka-ching, ka-ching. Therefore, OE is equal to square root of 3 over 2 y minus x. Yeah, I think if we had left it maybe like this, you probably have gotten like 4 marks. But the key thing here was spotting the difference of 2 squares, you see, because it's kind of not very clear, but it's there. See, 3 and the 4, square root of 3 and the 2. And that is that, you know, let's keep on moving forward. Let's keep moving forward to question 9.2. 9.2 says, in the diagram below, the center of the circle is O, yes, with the diameter KL, yes, yeah, okay. As long as this is the diameter, this angle is 90 degrees. We should know that. Then it says MNP is a tangent to the circle. NMP is a tangent to the circle. So we have the, you know, tan chord theorem there and the tan chord theorem there. Okay. So that being said, they said chords KN. Where's KN? KN and LN are drawn. R is a point on KR. Where's R? R is a point on KN. R is a point on KN. Okay. And ORSP. ORSP. Where is ORSP? Let's see here. ORSP forms a straight line. Okay. Then it says OP is 15. Where is OP? OP is 15. Okay, so the whole length here is 15. That's probably going to be useful. I don't know. Probably is, but yeah. So much information. Okay, not a lot. It's just like, it's all over the place. It's like, you know, ORSP, blah, 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 blah. For 1 mark, your ratios. Give the length of OR if the ratio of OR and RP is 2 to 3. Okay, so remember, the whole length is 15. Now they want you to get the ratio of OR and RP. So you need to share 15 using the ratio 2 to 3. You see, so if you're going to share 15 using the ratio 2 to 3, all you do is you add the 2 and the 3 together, you get a 5. And then all you say is 2 over 5 times the 15, 3 over 5 times the 15, you see. So you're going to get 2 answers, you see. This is going to be 30 over 5, which is like, what? Yep. Calculator, come and rescue us. Is a 6. Here, this is going to be 15 times 3 divided by 5. Going to get a 9. This phone won't stop ringing. Like goodness, yes, man. Yes, like. Anyways. So if you see the 9 and the 6 there, those definitely add up to 15, you see. And that's the idea with the ratios. And that's how it works even with, you know, proportionality theorem and everything. It's just a matter of adding up what you have. And then the 2, you divide by the 5. The 3, you divide by the 5. So you have 6 and 9, right? So they wanted to get OR. Remember, OR is the one that's being represented by the 2. So here, therefore, OR is equal to 6. Nice, nice. Whether that's useful for now, we never know, bruh. You never know. So what we know is this is a radius, and they said this is a straight line. Whether it's perpendicular or not, yeah, let's leave that on for now. So for 2 marks here, they said it is given that k squared minus kr squared minus ko squared is equal to 36. Prove that OR is perpendicular to KL. Where is OR now? OR perpendicular to KL. We should prove that these are perpendicular. But what did they tell us though? They told us that KR squared minus KO squared is equal to 36. That's easy. It's literally Pythagoras theorem. Like, come on, bro. There's OR here and then there's K up there, right? So definitely here we know that KR squared is equal to KO squared plus OR squared. So as long as we can see that OR is equal to 36 here, and then we have KO here squared, KR here squared. We have the no, it's 6 squared, bro. 6 squared, not 36 squared. So okay. That's it's a 2 mark question, yes. It's kind of straightforward, yes. But then the question would be like, okay, wait a minute, where does Pythagoras even come in? And the other thing is, I'm thinking to myself, did I leave out a question? Yes, I did. I left out 9.1, of which 9.1 was proving a theorem. This is just dumb. I feel like I have let myself down. But the thing is, the 10 chord theorem is something that we've proved like so often, like so often in the past that you know what, it is what it is, man. It is what it is. So let's see here. I mean, like, one way or the other, what do we know? Yeah, this is just Pythagoras theorem really at play, because come on, bruh. I feel like this is one of those questions where the way you're gonna prove that this expression is the way it is just quite dumb. Like, it's really the dumbest thing ever, you know? Because what you have here is you're gonna have kr minus ko squared. I mean, kr squared, ko squared equal to 36. You see? Of which here, you know that technically speaking, you have written this down. I mean, like, one way or the other, right? To be honest with you, these are really one of those weird questions where what we know is here, even if you maybe did not start like this, right? What you already know is that OR is equal to 6. So if you square OR, you know that you get a 36, you see. So what you then also can see is that what you also know is that from having to have written all this, right, we know that if these are perpendicular, then we would know that OR squared plus our KO squared, we know that this is equal to KR squared, you see. Of which, if you have OR on its own, you would have here KR squared minus KO squared. The OR, you mentioned that it is equal to 36. So 36 here is equal to, before you even write out what you're gonna write out at the end here, we know that the reason for you writing this out here, you're basically trying to say that the only way that this is going to be 90 is if this plus this squared is equal to KR squared. Now you're writing this out. Your reason here can just be converse of Pythagoras. This is where math really seems to be dumb, because it's like, wait, what? Then it's like, yeah, you just basically use Pythagoras theorem to say that, okay, the only way these are going to be perpendicular is if this squared is equal to this and that squared. And with our case here, we can see that the OR does represent a line where if you square it, it does give us this 36 that they're talking about there. You see, so the 36 there, we know that it represents OR squared. You see, so with writing out what we have written out here, we have shown that OR is 6, but then OR is actually equal to 36. So where we see OR there, we just dropped. Where we see 36 there, we just dropped OR. And then that's good enough to say that our two lines are perpendicular. Therefore, OR perpendicular to KL. Let's just keep it moving, because 3 marks, they said prove that OR and L is a cyclic quadrilateral. Okay, OR and L is a cyclic quad. So this one is quite simple because you can already see those 90-degree angles here facing each other. Opposite angles of a cyclic quad have to add up to 180. And because these are both 90, we're good to go. But we just have to tell them that we know that N2 is 90. We haven't told them yet. N2 is got to 90 degrees. The reason is angle in semi-circle. You see, because it's an angle inside half a circle. See, this is exactly half a circle. It's an angle subtended by the diameter of a circle. So this angle here is 90 degrees. So here we can say, what do we also know? We know that O2 is got to 90. We have proven that. O2 is got to 90 degrees. We proved it when we proved that these two lines are perpendicular to each other. So here we can say, therefore, O2 plus N2 is got to 180 degrees. Therefore, OR and L is a cyclic quadrilateral. Yo. This is why you should not write the full thing, because it's like, bro, you run out of space. The cyclic quad, because opposite angles are supplementary. Yep, but I feel like I should write this one nicely because it's like, bruh, come on, just write nicely. Supplementary. Whew, okay. Let's move on here. So it says here for 4 marks, right? MNP is translated to the left of the circle. Yo, they're busy talking some very non-interesting stuff here. It seems like it's just going to make this question weird, but it's a 4-mark question, so we would not need to panic too much. What's going on here? You come on now. When's in Johnny? What is going on? Like, we're trying to just do something simple here. Copy and paste. But you're not pasting. Oh, you're working now. Thank you. So let's see here. Cosop. And then Cosop. Hey, what's going on? Cosop. Fantastic. It's all good. We love it. So with all this being said, right? They said blah 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 blah. No, they said MNP. There's MNP, right? Is translated to the left of the circle. So it's a line that it's moved to the left. So it's gonna be like somewhere here. Wait a minute. It's gonna be like somewhere here or somewhere there. It doesn't matter. They are moving it to the left of the circle. Such that the new point of M. So what they mean is, if you're moving it, right? This line, MNP, if you're moving it, you're going to have a new P over here, a new N over here, and a new M over there. That's the idea behind this question. So what they are saying, though, is that keeping that in mind, what did they say now? Such that M falls outside the circle and N inside the circle. So what they mean is, if you're moving it, right, they want you to have M being outside, but then N has to be inside. And then it says here, the new value of P coincides with the point S. So what they mean is, you're going to move this line until it looks exactly like, let me just actually draw it exactly what it's going to be. So this is the original line, right? What they're saying is they want to move this line until it looks like that. Perfecto is looking good, is looking nice, is looking fantastic, is looking, yeah, I think you get the point. So you are going to have like a new point P over ISO. You can have a new point P, a new point N somewhere here, and a new point M somewhere here. That's going to be your image. And then it says here, the points OLS is O, L, and S. Okay, those points there, OLS the points, let's see again, the points, the points OLS remain fixed as indicated in the original diagram. What? In the original diagram? Okay, yeah, so there's O, there's L, there's S. They are still where they are, right? And then they said here, and NMP, so these are parallel to each other. And then it says, is it possible for these new points here to be a tangent to the circle drawn through O, L, S? What a wow. What a wow. I'm just like, wait, what? So to be honest, if you see this kind of a question and you're not done with the full paper, just move on, come back later, you know. So let's see here. They're talking about a line that is technically gonna be like here, or a triangle. They're talking about a circle. They're saying, would this orange line be a tangent to a circle that passes through these points? Now, the one way to always work out questions like that is always think of the 10-chord theorem. The 10-chord theorem is like your hack, because if you're going to have a circle that passes through these points, right, it means that there has to be a 90-degree angle somewhere inside your sketch. Like, it just has to be there. Because if you look at it nicely, I mean, like, we can go all the way here. Let's even draw the circle itself, you know, because we're finessing this thing. I need you to try to finesse us. So you must finesse them also. So let's see here. The way it looks, the circle would need to, come on, bro. I cannot what? Nah, come on, fam. Come on now. Oh. No, come back. Come back. Hi, man. I'm trying to, you see this thing is trying to cheat. I'm trying to hold the thing. It's just buggered up. Anyways, I'm sure you can see that this would have been a circle. It looks like an oval now, but let's just pretend it's a circle. So they're saying, would this orange line be a tangent to this circle here? So working that out, we definitely need to be creative a bit. If you're not creative, maybe this question is going to not be very nice for you. So we need to think outside the box. So firstly, I mean, just by the way it looks, it doesn't look like it is going to be a tangent to the circle, mainly because, I mean, these sketches are to scale anyways. So if this is going to be true, right, we need to just prove that the angle here would be equal to, well, let's see, this is the tangent. No, man, what am I saying? It doesn't make any sense, bruh. How many marks is this question? 4. Hi, Bowman. Which circle are they talking about? Is it possible for this line to be a tangent to the circle drawn through O, L, S? How? If the circle is drawn through O, L, S, the only thing that's really annoying is that it's a 4-mark question, but it doesn't seem like it needs us to do a lot, because it just doesn't make sense, you know. It really doesn't make any sense. It doesn't make any sense at all. Like, it really doesn't. It feels like we need to have arguments against the fact that the circle won't be will not have the line as a tangent. We just need to have arguments against it. Like, we literally just have to have arguments against it through and through. So the first one is that, firstly, this new line here, M and P, this new line, everything, all those points, we can easily just see from this sketch that the line touches the circle more than once. Like, it really does. Like it really does. So this is really one of those really annoying questions. I keep saying the same thing, but yeah, it's just one of those, like, why does it look so dumb though? Like, why does it look so dumb though? Like, okay, I think I'm just being extra right now, but So what we know is if you had, okay, let me just, this is literally one of those questions where you're gonna have to just write it like a mini essay, not an essay per se, but you're gonna have to write something. So firstly here we know that O2 is 90 degrees, right? This has been proven. Therefore, LS would be the diameter. That's point number one. You see, this is a diameter. So if you look nicely, the tangent, if this was a tangent, right, it would need to be like it does not, it's not working here. But let's just see, LS would be the diameter. Okay, fine. Where am I going with that point? I'm going with the way I'm going with this point is I'm trying to say that the center would be like somewhere here. Okay, perfect. Now if the center is there, it means that, remember, your tangent and your radius would need to meet at an angle of 90 degrees. So this would be like the radius, it would need to meet the tangent at an angle of 90 degrees, and that's not happening. So firstly here, the radius is not perpendicular. Is how you write perpendicular? I don't know. Let's not write it even. Yeah, but perpendicular. This is how you write perpendicular. I hope so. I hope so. But I have the laptop in front of me. I can quickly Google it because my brain has gone. It's not working anymore. It doesn't want to think. So let me see here. Perpendicular. Come on, internet. Oh, yeah, I spelled it correctly. Oh my gosh. I'm smart. I'm not a block. Yeah, the radius is not perpendicular to M N P. That's so plain. It's so in our face. But it's a 4-mark question, so I think we just need to get other arguments against what they have told us here. So this could be one argument. We can write the others up here. You see, so this is like argument number 1. Where is this thing now? Argument number 1. Catching. Secondly, 10-chord theorem, right? So if this was like a tangent to the circle, it means that the tangent here and the chord there, the angle opposite there would need to be equal to this one, you see, but that's not happening, you see. So here, LSM, so here, let me even write P here, LPM is not equal to O2, you see. So that's not true. So here we have no 10-chord theorem. That's another thing to disprove that the fact, to disprove the fact that we really cannot have a circle in here. You could think to yourself, but then can't we like think of maybe another law or another reason why that line is not going to be inside the, why that line is not going to be a tangent? We could look some more, you know, but yeah, it really feels like, you know what, we're just wasting our time here. But yeah, let's just look some more. Let's just look some more. So where is LSO? LSO is a 90-degree angle. Yeah, so we said it's not, these are not equal because of the 10-chord theorem. What else? This is just dumb. This is just dumb. Like it really is. It really just feels dumb. It looks dumb. But then this is all good. There's a statement and a reason. Statement and a reason. That's going to give us 4 marks, you see. Because the first statement here is that the radius is not perpendicular to this. So therefore, we can say therefore, what what you call, the radius is not perpendicular to the tangent. So therefore, LS, which is the diameter, is not perpendicular to thingy. Wait a minute. So therefore, Wait, the radius is not perpendicular to this. So we can just say, therefore, no 10 perpendicular radius. So we don't have this going on, and we also don't have the 10 chord theorem going on, you see. So that's good enough for 4 marks. Let's just move on from this really, really wretched question, because question number 10. Yeah. June and November papers are the same, ne? But don't let anyone lie to you and say prelims are the same as June and finals. They are not. Prelims whip if you didn't study. So it says here, two circles touch each other internally. So they touch each other, and then it says B, yeah, they touch internally at B. And then it says O is the center of the bigger circle. Okay, so it means the diameter of the smaller circle is the radius of the big one. And then it says here, yeah, it's O is the center of the bigger circle, lies on the circumference of the smaller circle. Okay, fine. FBG. Where's FBG? FBG, where are you? FBG is a common tangent. You whoever set this paper name was angry. I don't even want to lie, they were angry. Then it says A, B, and BC are chords. A, B, and BC are chords of the bigger circle. Yes, they are. And then they say it here, and intersect the smaller circle at D. And then at E respectively. So this sketch looks a bit cluttered, but it's fine. AHG forms a straight line. Yes. Chords OD, where's OD? There's a chord OD there. DE, and then OB, they're just chords of the smaller circle. And then they gave us a ratio. AH and AG is 1 to 2. So that kind of looks like it's going to help us, especially how we have a parallel line here. Another line that's parallel there. So already with this triangle here, we can see we're going to be doing some proportionality theorem shandies here. Definitely, like you can already see, yeah, it's going to go down there. It's going to go down. So for 1 mark, they said, why give a reason why B4 is equal to HCB. Where is B4? B4 is here. HCB is here. Wow, why do they have to be so extra? So they're talking about B4, which is here. And then the angle, the other angle, HCB, is over here. Wow. Well, I'm thinking of the 10 chord theorem, but at the same time, this is here, but it's not the 10 chord theorem here. These are alternating angles, you see. Yeah, just say alternating angles. Alternating angles. It's not the 10 chord theorem. If you say 10 chord theorem, you're wrong, because it's a point on one side, one point of the big circle, one point of the big circle, but then this one ends up in the small circle. So don't make the mistake of saying 10 chord theorem here, because nope. These 3 points would have needed to be in one full circle. They're just equal because they're alternating angles. They say give a reason why B4 is equal to D4. Where is B4 now? B4 and D4. This one now is because of the 10 chord theorem, because you see in this small triangle here, you already have the 10 chord theorem. Lucker. So 10 chord theorem. 10 chord theorem. With this specific similarity question, right, where they're asking us to prove that these two triangles are similar. Now, the one thing you can take note of is, let's look at these two triangles. They're talking about triangle DBE. So triangle DBE is like DBE. It's this small triangle over here, right? Let me maybe write it in purple. There's triangle DBE here. And then secondly, there's triangle DBC. Okay, so where's DBC? DBC is D, B, and then C. So there's DBC here. Let me just write that in red maybe. So there's DBC, which is like the bigger one here. There we go. There we go. Now, if you look at it nicely, right, the one thing I always say is normally the way they label these is usually supposed to help you to like see which ones you're going to use to say are equal for you to prove similarity. Because if you're going to prove similarity, the one thing you need to do is to prove that all 3 angles of your 2 triangles are equal to each other. Like two pairs, all three pairs are equal, like one equal to the other one equal to the other one, and then the third one's equal to each other. That's how you prove similarity. And the one thing you'll always hear me say is that normally the way the question is laid out almost gives you a hint of which ones you should like pinpoint out to be equal. Now, this question is not like that, funny enough, because if you look at where D is here, right, for the purple triangle, and where D is for the red triangle, those are definitely not going to be equal to each other, you see, because for the purple triangle, right, DBE, triangle DBE, the D is this green part here. For the red triangle, right, DBC, DBC, the D is this whole thing here. So you can clearly see that the D for this triangle and this one here, they don't match. So you cannot now use the idea to think, okay, let's try and show that these are equal. Let's try and show that these are equal. For this specific question, yeah, it definitely doesn't seem like that's the case. So this one, we don't have any hints from the question. We just have to work with what we can from the sketch directly. Fortunately, in the previous two questions, right, we have shown that D4 and HCB, they are both equal to B4. We've shown that in the previous two questions. There was alternating angles and Ten-Court theorem. So because D4 here and HCB are both equal to B4, it means that they're equal to each other. That's something we already know. So we might as well even start there, right? For the two triangles, we can start by saying D4 is equal to this angle here, right? Which is just angle C. They're equal because we've proven that already. You see, it's been proven. The second pair of angles that we're going to show to be equal is this one here. This is just a common angle in both of them. So we can label this one DBC, right? Let me write this out here. I'm waiting for this down thing here. DBC is equal to DBC. The reason is it's a common angle. Now the rule of thumb is anytime you have at least two pairs of angles that you've shown are equal, the third ones you can automatically say they're equal because of the sum of interior angles of a triangle. So the green ones are sorted, and then this one is also sorted. So clearly the only one that's left is this tiny one here for the one triangle, which we can call E2. So we're gonna say here E2 is equal to this one here for the red one, right? Which we can call CDB. CDB. So we're saying these are equal. The reason for that, we can just say here sum of interior angles of a triangle. Perfect. So we have proven that three angles are all equal to each other. These three are equal to these three. And that's the whole game with similarity. So we can then say here, therefore, the two triangles are similar. Now, if you're going to name these triangles, the best thing you can do for yourself is to name them according to like the angles that like match, you see. So let me maybe not even, mark these white ones because they're just going to make things a bit annoying. So I think we can name these triangles according to, we can start the first one, the purple one, we can maybe call it DBC. So here we can say, therefore, triangle DBC is similar to triangle, so say here we started with the D for the other one, right? This one, it looks like we proved that the D here is equal to the C there. So we might as well start with the C for this one. B was a common angle for both. So where there's the B for this one, we can put a B for this one as well. So meaning this one, we can just call it CBD. CBD. You see, the reason why you want to do stuff like this is it helps for when you do your whole proportionality expressions and all that. So we have proven that these are similar. The reason for that is just angle, angle, angle. Now, if you chose to write this statement out the way they gave it to you up here, it's fine. It's just not advisable because if you do it like this, right, when you will be doing your whole proportionality expression stuff, it's not going to be accurate because the way these two are written out, they don't match. The angle here does not match that one. The angle there does not match that one, blah, blah, blah. Okay, they do, those two match, but the rest don't, you see. So you want to wait, did I make a mistake here? I think I did. Where is E? No, hold on. DB. Yeah, I didn't make a mistake. Hold on. Let me see here. DBC. DBC. I think I meant DBE and CBD. Yeah, I think this one I meant E. DBE. Let me just correct that because it doesn't make any sense. There we go. So DBE is the small one in purple. DBE. Let me just highlight the B here. And then also the E, because those are a bit overshadowed. So there's a B there, and there's a D over there. So the purple triangle, we've named it DBE. And then the big one, we have named it CBD. Okay, those match. That's all good. It's all nice and dandy. That's just out of 3, right? Before I move on, let me maybe check if there are any questions, because if there are no questions, then we definitely might as well move on. In the chat section, no questions. Perfecto. So in terms of moving on, right, the one thing we can take note of is, okay, fine, it's a 3-mark question here, and in this 3-mark question they want us to do what? We're supposed to be proving stuff, right? So here they want us to prove that D is the midpoint of AB. Now, the one thing you want to do for yourself is, I mean, let's just maybe bring the sketch a bit lower here. So whatever you're going to be asked in follow-up questions, right, don't forget what you would have just proven. It's one of the worst things you can do for yourself, because whatever you would have just proven, try and make use of it to help you answer follow-up questions. So let's see where D is here. D in particular is this point here. And AB is this long line here, right? It stretches from A up here all the way to down here. So this is quite interesting. It's like super okay. It's not that interesting, but it's worth what? It's worth considering, or it's worth labeling as a not so straightforward question, in my opinion. Maybe it's just me. They want us to prove that D is the midpoint of AB. So obviously, if D is going to be the midpoint of AB, it also then just means that AD is equal to BD. So that's one way to look at it. And to be honest, as I'm looking at this 3-mark question, right, like, funny enough, my head does feel a bit blank. I'm literally like, wait, what do we do? And the sad thing with most math questions is, when you're going to be looking at a question, right, the first thing that your brain does is it firstly tries to compare it to something that you may have seen in the past. Now, like, which is, I'm just literally talking from what is happening in my own head right now. In my head right now, the one thing that's going on is I'm thinking to myself, okay, fine, have I seen a similar question like this before? And I don't even know if it's a yes or a no question yet. I'm yet to think about it. So let me see here. On the group, it says angle in semicircle. Let's see. Well, we have, what do we have here? We have this as a 90-degree angle. And what else do we know? Angle. I don't know what you mean by angle in semicircle. But I see you said that Leo said something in the group. Let me just add our fellow comrade Hiso, and then we can carry on. So I see angle in semicircle. So in our small circle, right, what we do have is the diameter, which is this line over here, of which, as long as we have that, we have this triangle over here, of which in that triangle, we know that this angle here is a 90-degree angle. Oh, dang it. That just made something click. So let me see here, 2 angles, the angles on a straight line. Oh, okay. Yeah, let me actually respond to the group here, because yeah, definitely that does work. Oh yeah, just put here, oh yeah, boom. Yeah, so definitely, okay, so if you focus on the big circle now, right, everything just makes sense why this is like a 3-mark question. Because if you look at the big circle, we have the big circle, right, and we have center O, right? O goes to D, right, of which D is on AB. You see, so there's A up there, and there's B down there. There's B down here, there's A up there, you see. So this is clearly theorem 1, right? Of which theorem 1 basically states that a line from the center of a circle, it bisects a chord in half if they meet at an angle of 90 degrees. So in terms of us getting 3 marks, the first thing we need to tell them is that ODB is a 90-degree angle. So let's just say that first. ODB is equal to 90 degrees. The reason is angle in semicircle. So since this is an angle in a semicircle and we showed that it's 90 degrees, we can then say, therefore, OD is perpendicular to AB. It's more of a conclusion. So as long as we've said that OD is perpendicular to AB, we can then say, therefore, AD is equal to DB. The reason is line from center bisects chord at an let's just say line from center meets chord at an angle of 90 degrees. Line from center meets chord at an angle of 90 degrees, you see. So what we saw is that there's a line from the center meeting a chord at an angle of 90 degrees. As long as that's happening, it means that these are equal to each other. And as long as those two lines are equal to each other, it is enough for us to then say D is in the middle of the line AB. You see, so as a conclusion here, we can say, therefore, D is the midpoint of AB. Whew, 3 marks. So yeah, Danko, thank you very much. Thank you, because that was, like I said, blonde moment, and blonde moments are not fun. But anyways, it's all good. It's all good. It's all good. Teamwork makes the dream work, clearly. So moving on to the next question, right? Probably gonna ask. It's probably asking us to prove something else, because all these questions we need to prove something. You see. So the first one wants us to prove. We proved whatever. The second one we proved whatever, and then the third one we're proving whatever we're proving. So anyways, what do I need now? What do I need? The next question is out of 4. So this question out of 4, we can see there's some, ratio stuff happening here. And the one thing you can also keep in mind is whatever information they give you right in the beginning of your question, if you find yourself not having to have used a certain portion of your question, then the more questions you're going to do without using it, the more likely you're going to end up needing to use it. See, like this thing here, we haven't even touched anything about it yet. But if you look at the questions left for question 10, there's just like 2, no 3. Well, whichever way, we might need it for this 4-mark question, but we'll see. So 10.2.3 says we should prove that AB squared over 4 is equal to this. Okay, so obviously this is some ratio stuff. So usually in terms of like a train of thought, right, based on what I also mentioned in the previous question, if you can recall from the previous question, the one thing I mentioned was that anytime I'm looking at a question, or anytime we all look at questions, the first thing we think of is, have we seen something similar? And we try to think of it like that, of which we have all seen questions similar to this. And based on that, right, the one thing that is to be done when you see ratio and proportion questions is to try and figure out where within your sketch did you do some kind of similarity stuff. We proved similarity here, right? However, if you look at the lines that we're dealing with here, A, B, B, C, and all that, I mean, like, if you think nicely between these two triangles that we proved to be similar, there's no A anywhere. So focusing on these triangles here for this question, it doesn't look like it's going to work. But what looks like it's going to work is our ratio and proportion sketch thingy-majiggy going on here. Let me just show you what I mean. So if you look at our sketch, right, it is clear that we have these lines here that are parallel to each other. And then in addition to these parallel lines, we have, what is this? In addition to these parallel lines, right, we have this. This is like AG, and this is like AB, you see. So just by looking at this, we have like the whole what you call, looking at this sketch, we have like the whole proportionality theorem type of thing going on, you see. So that's one thing to keep in mind. We have the whole proportionality theorem. Ooh, what is going on with the network today? It seems like everyone is falling off the bus, but it's fine. We'll keep adding our fallen comrades. And let me actually just mute this thing because it keeps on going boom, 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 and it's like, bruh, come on, bruh. So let me just mute this. Okay, let's carry on. So I think I kind of like sidetracked. So the one thing I'm just to regroup, it looks as though this sketch may be what's going to help us, because we already know that in the beginning they told us that the ratio between AH and AG is 1 to 2. And let us mute the mic. Oh, it's muted. Nice. They told us this ratio. So we know that the ratio between this and this is this 1 to 2, which is fine. The fortunate thing also is that we proved that this is where things get a bit funky. We proved that this line here is equal to this line. Now, without confusing anyone, let me try and explain this nicely. We know that the midpoint theorem basically states that if you have a line inside a triangle, right, that cuts one side of your triangle in half, and it also cuts the other side in half, it means that these two lines here, the ratio between them is just 1 to 2. Now, the fortunate thing is, without us knowing that this ratio here is 1 to 2, as long as the ratio between AH and AG is 1 to 2, it is enough for us to be able to say that this is equal to that. And I'll explain why just now. So if you look nicely, right, anytime you deal with the proportionality theorem where you see a sketch like this, technically speaking, what you're dealing with is triangle AHD. So you have AHD there. I'm just write out AHD. And you also have triangle AGB. Triangle AGB here. You see. Now, the idea is, as long as you know that the ratio between AH and AG is 1 to 2, it means that the ratio between any other side is also going to be 1 to 2, meaning the ratio between GD and GB is also going to be 1 to 2, because that's just how similarity between triangles works. You see, the ratio between any two sides that are like matching is going to be the ratio for any other two sides. So automatically, as long as we know that AH to AG is 1 to 2, it means that the ratio between HD and GB is also 1 to 2. And as long as that's happening, it means that this is cut in half, this is also being cut in half. I think that's just maybe additional information that we can always keep in mind. So this is also to say, don't look at things in isolation. You see, one piece of information that you get gives you an opportunity to supplement other things that you may already be thinking. So from here, it's a 4-mark question. I think let's maybe try and see how we can end up with this. And I'm thinking the whole proportionality stuff might help us. But again, let me try and be a bit more composed, because I feel like I'm just going in circles here. Anyways, let's see. So we have AB squared. AB is this whole line over here. And then we have, what else do we have? We have BC. BC is, this is where things get a bit crazy, because BC is literally this line over here, which is looking like it's something from like a totally different triangle. And then there is BE. BE is this tiny part here. Yeah, so the way it looks, excuse me, it doesn't look pretty at all. And the other thing is also, it's just a 4-mark question, so it doesn't seem like we want to overthink it, but it also doesn't seem like we want to underestimate it. So in terms of what is going on in my head now, the one thing I'm thinking is, okay, fine, it looks as though we may have to use this some way, somehow. It looks as though we cannot avoid using this for something. So we might as well have to bring it in. We might as well bring it into our question. Now, the first thing you can do whenever you're dealing with a pair of triangles that you have proven to be similar, and you're dealing with, ratio and proportion and all that, the first thing you can do is to write out your proportionality expression. You see, so meaning from here I can write out dB over CB. So there's dB here, dB over CB is equal to BE over dB is equal to BE over dB. No, BD, sorry. which is also equal to DE over CD. DE over CD. Okay. So the way I'm doing this is, it's literally, remember, everything is on the fly. It's not like I'm trying to remember something I did in the past or whatever. Nope. It's just literally what my brain is thinking. So having to have done all this, the one thing we may want to do is to look at what do we have in our question that we also have here. Now, the only thing that we have that seems to be useful to us is, for example, here there's like a BE, right? There's a BE here. In our question here, there's like a BC somewhere, of which this qualifies as BC. CB or BC, it's the same line, you know. So it looks as though from all this being written out, we do know the reason for writing it would just be, you can just write here proportionality theorem, of which, having to have written out all these three, right, it looks as though only these two are useful to us. Now, the fortunate thing is, if we just focus on these two, right, it looks like we are probably maybe at least going somewhere. Because if you're focused on just these two here, what you have here is, let's maybe even write it on its own, right? So here we have DB over CB. Let's maybe write it as BC, you know, just so that it at least matches what we want. And then here we have BE over DB. Now it looks as though for us to get BC and BE next to each other, from here we can just maybe cross multiply. If you cross multiply, you're going to have this times this, which is going to give you BC times BE, equal to this times this, which is like DB times BD. Ah, would you look at that? This is very promising. The fortunate thing is, remember, DB and BD is the same thing. These are just swapped around, but it's the same line. If you look at it in your sketch, right, where is DB? DB is this line over here, of which DB is the same line as if they write it as like BD. It doesn't matter. So these two being multiplied together, it's the same line, right? So we can just write here BD squared, because this times itself is just going to be this squared. And then here you have like BC times BE. Now, out of 4, I think here we probably have at least 2 marks, because it looks like things are low-key starting to work together, you know, because from what we're trying to prove, we have the right-hand side already. We just need to show that this left-hand side can be, we just need to show that we can go from here to this. Now, it doesn't look like that's going to be very difficult for us to do. Fortunately, because if you look at it nicely, right, BD is just half of AB. I'll repeat, BD is half of AB. Like, it's so clear in our sketch, and we can even say that because of the previous question also. They told us that D is in the middle of AB. So BD is half of AB. And since we want to have AB in our expression, we may want to replace this with something that has AB. So instead of us writing BD here, we can just put the half AB, because that's what BD is, right? It's just half of AB. And then the moment we have done that, we are clearly home free. Of which here you can see a half squared is just going to give you a quarter. And then AB squared is just going to give you AB squared. I mean, AB to the power of 2 is going to give you AB squared. And then here you have your BC multiplied by your BE. A quarter times this, I mean, like, this is technically over 1, you know. So this times the 1 gives you AB squared. 4 times the 1 there gives you 4. And then here you have your BC multiplied by your BE. There we go. You're going to get your 4 nice marks here. Now, the funny thing is, you may be thinking, but bro, you were talking about this 1 to 2 half here. Why? To be honest, that's what was in my head, you know. So the idea is, whatever question you get, you don't want to just dwell and just not know what to do. Do what you have to do. If whatever we're thinking here, right? The one thing that, like, maybe somewhat resulted in us moving away from thinking all this is because here they spoke of BC, and BC is automatically like a line that's like, you know, there, and then BE also. So that's what brought us back to just thinking of this, which is what we kind of pointed out in the beginning, to say anytime you see ratio stuff, think of where you have proven similarity before and start there. But then I also did mention that in our description, as long as you see that there's something specific that you haven't used and you keep going on with questions, it means that it is highly likely that you're going to need to use it in like a follow-up question. And here there are only like 2 questions left, right? So chances that we're going to make use of this are kind of high here for 10.2.4. But let me see if there are any questions. So nope, everybody seems to be on board, which is good. So with 10.2.4, right? 10.2.4, what does it say there? It says for 3 marks, what do we have? We should prove. So whatever we're going to prove now, we might as well also bring our sketch along, because as long as you can always refer to your sketch, you're good. Don't leave your sketch alone for too long. It's going to divorce you. So anyways, let's see here. CE, where's CE? CE is this line over here. They say we should prove that the ratio between CE, we should prove, right? Remember the question is starting, all these questions, we're supposed to prove that. So here it's saying prove that CE, the ratio between CE, doesn't look pretty at all. The ratio between CE, oh, come on, brother. Come on, man. Between CE and BC, where is BC? BC is the whole thing here. Well, let me put it this way. We should prove that CE, the ratio between CE and BC is 5:9. If a clear mind again. So with 10.2.4, right? It's a 3-mark question, which is a bit comforting because, to be honest, 3-mark questions, just like how this one proved to be not so crazy, that's what we can be thinking of with this 3-mark question. They say the ratio between CE and BC, so meaning CE and BC, the ratio there is just 5:9. So we should prove that the ratio is 5:9 if DB is a 3. So they're trying to tell us the length here. So they've told us that this is a 3 and BE is a 2. So they are giving us actual lengths here, which is quite interesting because normally they don't like give us specific lengths to work with. But the other thing is, what we do know is that like we have sides that we proved to, we have triangles rather that we proved to be similar. So in as much as we may want to reinvent the wheel and be all fancy and whatever, we might as well just start here where we have proven that these 2 triangles are similar. And then from us having to have proven that those 2 triangles are similar, we know that we wrote out our expression. So we might as well, with this question, start here. It seems like a good place to start. Firstly, because it's just a 3-mark question. Secondly, because they're asking for us to prove a specific ratio. So we know that these 2 triangles, we proved them to be similar to each other. And then now from that, we were able to write out these expressions. So what we definitely want to just do now is the same thing we did. There is CE here. We want to look for CE over here. We don't see anything to do with CE. But if you look at our sketch, CE is a portion of the line BC. So this somewhat has some merit. And then here there's like BC, of which this is actually BC. And then amongst the information they've given us, there is DB somewhere. So there's a DB here somewhere. And then there's DE. And there's DE there. So it looks as though amongst all these 3, these 2 are what we can use, because they seem to be the ones that have, the information that they have spoken about here. There's a BC there, there's a BD, which is like there, or DB rather, it doesn't matter. And then there's like BE up there. So let's just take this as a starting point, right? So with these 2 fractions, what we can do is put the lengths that were given. So here we have DB, which is a 3, right? So if you put a 3 here, CB, we don't have any CB given, so let's just leave it as CB, or let's write it as BC rather, because of that. And then here BE, they gave it to us as 2, and then DB, which is the same as BD, they gave it to us as 3. Okay, fine. So the funny thing is, okay, it's not like haha funny. The one thing you definitely don't wanna take for granted is the fact that you have one ratio over here. Right? This is the ratio 2 to 3, and then there's BC on its own. So in as much as we are trying to get the ratio of CE and BC, getting BC first looks like something that's gonna help us. So let's just do that first. So to get BC, we can cross multiply first. It's gonna be 2 BC. Or maybe not. Let's maybe pause here. BC, we said it is literally just a combination of two lines. No, I think I'm just overthinking it. Let's just get BC first, and then we'll think some more afterwards. This times this gives us 2 BC. 3 times 3 gives us a 9. And then if you divide both sides by 2, the BC is just 9 over 2. Okay. Now the fortunate thing is, remember here we're working with like the actual length of these lines. So BC being 9 over 2, that's like the actual length of like the line BC over there. So with that being said, it doesn't look as though proving that the ratio between this line and this line is 9 to 5. It doesn't look as though this is going to be difficult. The reason why this is not going to be difficult is because if you think logically, right? We have B here, we have C there, and then we have E in the middle. You see, we know the length of BC and we know the length of BE, which is this small part here. So as long as we know this full length and we know this small length, we can easily get CE, you see, because if you look at it nicely, CE is just whatever BC is minus whatever BE is. It's just a very logical statement. The whole BC, if you minus BE, you're going to be left with CE. So let's get the length of CE. The length of CE is going to be 9 over 2 there minus BE, which we were told is 2 units, of which this we can just put in the calculator. So let's put all that in the calculator and see what happens. And let's rejoin Amy. I think her network is like teka-teka-ring there, but it is what it is. So 9 over 2 minus 2 is giving us 5 over 2. So that's very promising. You know, there's 5s and 9s, it's all good. So we have the length of CE and you have the length of BC. So if you're going to come up with this ratio, it's quite simple because remember, ratio means divide. Technically speaking, CE with BC there is the same as CE with BC down there. So you should just prove that this over this is 5 over 9, you see, because ratio means divide. So when you see something like this, you should easily be seeing something like this. When you see something like this, you should easily be seeing something like this. So our job is to just show that if you take the length of E of CE, right? Let's write here CE over BC, right? We are gonna write here CE is just 5 over 2, and then BC is just 9 over 2. So let's put that there. And then we should just show that this in its simplest form is just 5 over 2. I mean 5 over 9. It's as good as putting the ratio 5 to 9 there. So this in your calculator, let's see there. Fraction, we have 5 over 2 and then divided by 9 over 2. The answer that's coming out there is 5 over 9. You see, so here you can then say, therefore, the ratio between CE and BC is just 5 to 9. There we go. And then you get 3 marks. We can see here, these 3 marks, we didn't exactly like sweat for them or anything like that. We were just doing stuff. Like literally, we just literally used the same thing twice in 2 different questions. And it gave us what we need, you see. Because it goes back to not thinking that your questions want you to do something very special. They clearly don't. You know, they clearly just don't. And we've been talking about this whole 1 to 2 thing for so long right now. It's almost getting stale. If we end up not using it here, it's going to be like, uh-oh, maybe we used it some way, somehow. I mean, I don't know. It is what it is. Let's just carry on with this 6-mark question now and see what we can do. So they say that we should calculate the ratio. Do we even remember to record again? Oh, we did. I was about to leave my West nightmare. Okay, not necessarily, but anyways, it's a 6-mark question here. And again, we want the sketch because whatever the sketch is, yeah, it's necessary for us to use it. So let's see here. It says here, calculate the ratio of the area of triangle AHD. Let's see what AHD is. AHD, there is A here, H there, D there. The other triangle that they are talking about is HGB. So there's H, G, woo, B. I don't align it. That just escalated so fast because it's like, wait, what? What? Like what? So AHB, we kind of even have to draw it. So it's like, yeah, it is not this question. Yeah, obviously I'm probably just exaggerating, but at this rate, it's literally throwing hands. It's throwing some serious hands. But that's just me talking. You know, it could be, it could not. We don't know. We'll find out just now. I think I might as well make this like a proper full line instead of like a dotted one, because I mean, let's give the question a bit more krach. You know, let's respect the question. So, oh wow, that doesn't look bad at all. It actually does look. Oh no, this line here, it doesn't look very bad. I'm trying to draw a straight line, but obviously cannot do it all in one go. So this is what we have, right? We have two triangles. There's triangle AHD. AHD. We should show that the ratio of the area of this triangle, we should get a ratio of the area of this triangle to the area of this triangle. So let me maybe just draw this full one in red completely so that it like stands out. And then let me draw this one also in red. Let me draw this one in green completely so that it like stands out. Now, as I'm like drawing out whatever I'm drawing out here, this is one thought that is coming to mind, you see, because the whole point with whatever is being done or whatever it is that you're going to see me do, I'm only going to tell you what is in my head. Like, I'm not like trying to, I'm not, as we're working out this question, it's all a matter of what is in my head and what is going on. It's not like some rocket science or whatever. No, honestly speaking. So for example, the one thing that is in my head right now is, okay, fine, it's the last question of the whole thing. You see, there's like 10.3 here. There's nothing that comes after this. Remember, this is from a past paper. Now, the one thing that comes to mind is the fact that these are equal to each other, and the fact also that these are equal to each other. But these two here don't necessarily matter for this sketch. I think what matters is that this is equal to this, and then what also then matters is the fact that this one is half of that one. And those are some of the things that kind of matter in our sketch here. So in terms of us knowing that matters, I think it's one of the things that we need to like state in our question to say we know this, you know, before we can make use of it. Because remember, in the sketch, what they gave us was this, you know, and then they gave us this ratio. They told us that AH to AG, the ratio there is 1 to 2. So what we can then say is, let's just try and put our mind at ease, right, by making it known that we know that these are equal, and we know that this is half of that. So let's just put that down. So the one way you can do it is just firstly start off with what they told you, you know, of which this is where I think, not I think, but this is where this is definitely coming in. This is something they told us, right? They told us this information here, right? They told us that the ratio between AH and AG is 1 to 2. They told us. You might as well write it out, and you can put given there, you know, just for the vibes. Them having to have told us that the ratio between AH and AG is 1 to 2, it literally allows us to then say, therefore, the ratio between HD and GB is also 1 to 2. The reason for that is line inside, line inside triangle bisects, bisects line AB and the ratio between AH and AG is 1 to 2. All this seems like it's all gibberish, or not necessarily gibberish. It definitely looks a bit useless, but it is what it is. We have put that there, and the reason for us doing that is so that we can say, therefore, AH is equal to HG. The reason there is the midpoint theorem. So maybe from the top, right, with all that we have written out here, the reason for us writing out all this is because in terms of like the train of thought for us to answer this question, the pieces of information that we have is, okay, we're dealing with two different triangles, and in these two different triangles, these two lines are equal. That may help us, maybe not, but we're putting it out there. Now, us putting out the fact that these two are equal, what it then allows us to do is we can now focus on the question specifically, because the question wants us to end up with a ratio between the area of one triangle and the area of the other one. So the reason why us showing that this is equal to this is important is because when we now focus on this question, right, what we all know is that regardless of how difficult or crazy this question may look, the area of a triangle, we don't necessarily have like many different formulas. There's literally only two we can think of when it comes to like the area of a triangle. When it comes to the area of a triangle, the first formula you can think of is half base times height. The second formula you can think of is the sine, the one with sine, right? The one that says a half times A times B times sine C. Let me give myself more space. I don't know, I read everything. So I'm just going to put out here, whatever we're going to do, right? We have two formulas that we can be thinking of. Half base times height, or half half AB times sine C. These are the only two formulas we can be thinking of. Now, if we're thinking of those formulas, I mean, it doesn't seem too far-fetched for us to what you may call, to also like introduce the fact that this angle here, we know that it is equal to that angle over there. You see, because those are corresponding angles. Now, as long as we are thinking of angles being equal to each other, right? Or rather, if we think of these two formulas as the only two formulas we could potentially use for the area of a triangle, this one here is, it looks a bit lacking, because a base and a perpendicular height, we would need to have some kind of 90-degree angle in both our triangles. And I remember, whatever our perpendicular height is, it needs to be a line that is going to be perpendicular to the base, of which having that in these two triangles, it doesn't look like it's going to happen. So I'm automatically almost ruling out this option. This option looks very favorable. The reason why this option looks very favorable is because in these two triangles, we have two angles that are already equal to each other. And we also have like two sides that are equal. And we know the ratio between these two sides of our triangles. So yeah, the more we're looking at this question, the more it's making sense. The more it doesn't seem very evil anymore. So after having to have written the fact that this is equal to this, right? The one thing that we're going to state is that this angle is equal to this angle, because what we eventually want to do is to put the lengths of our triangles and their information in this formula. We're going to do it for the top one, and we're going to do it for the bottom one, and we're going to see where that ends us, or where that leads us. So the one thing that you may be thinking of is all this here, but when we're done with the question, we'll just come back here to just clean up, you know, to just allow all this to like make better sense. So here, let me write out here AHD is equal to HGB. The reason there is those are just corresponding angles. Corresponding angles. Okay. I think we're home free now. So here now we can say, therefore, area of triangle AHD, the area of triangle AHD over the area of triangle HGB is equal to the following. So we can deal with AHD first. So AHD is the green one. So the area of the green triangle, we know, let me even write it in green. We're going to use this formula, right? So we know it's equal to a half multiplied by 2 sides multiplied by sine the angle. So the issue is whatever angle you're dealing with, these 2 sides have to be 2 sides that are next to this angle. So this is the angle in the middle. Your small a and your small b are going to be these 2 sides here. Same for the red one, right? So for now, let's write here, it's a half multiplied by one side, right, which we can label AH, multiplied by the other side, which we can label HD. HD, or let me not put brackets because that's looking a bit ugly. Let's see here, there's AH and HD. The whole thing or multiplying by sine angle there. So the angle here, we can call it AHD. There we go. We're going to do the same for the bottom. You see, because the area of the triangle here, HGB, we know it's going to be a half. And then the one side that we have there, we know it's like HG. It's like HG over there, multiplied by GB, multiplied by sine the angle there, sine. This angle here, we called it HGB. So let's put here HGB. Perfect. So at this point in time, everything seems like it's in place because a lot of things are just going to be canceling each other out. The half here cancels the half down there. Now, if you look nicely, remember AH is the same as like GH. So where you see AH up here, it cancels the HG down there. These we can leave them for now. However, down here, these are also going to cancel each other out. The reason is sine AHD is the same as sine HGB. The reason is these two angles are exactly the same. You see, we showed it here. The AHD, which is this angle there, and the HGB, which is this angle there, they're the same because of corresponding angles. So sine that angle is going to cancel sine that angle down there, which is going to leave us with HD over GB, of which we know exactly what this ratio is. HD is the line over here, GB is the line over there. And based on us having to have shown that, I forgot to finish writing it out here. Midpoint theorem was the reason for this question. We wrote midpoint theorem, right? So based on everything we wrote up here, right, where we know that a line inside this triangle is bisecting AD in half, we were then able to say, we know that AH is equal to HG because of the midpoint theorem. Without like making a big mess or a big fuss of anything, we have proven the midpoint theorem here, or we know that the midpoint theorem is at play. We already know that this is just half of whatever this is. If this is X, this is going to be 2X. So we already know what the ratio of HD and GB is without us like needing to like, do something fancy or something crazy. So as long as we have this written out, HD over GB, we know that the ratio here is just 1 over 2, because HD, which is this line here, is definitely going to be double this line over there. And just to re-emphasize what we mentioned, these two are equal and these two are equal as well, right? And you have parallel lines here. So it's all the midpoint theorem coming together. If you really want to put midpoint theorem here as well, I mean, you feel free to do it, midpoint theorem. You see, there we go. And I think coincidentally, I think it was offensive that was talking. that was talking about the midpoint theorem and like something about proofing and all that. So I think this is a very good example of where the midpoint theorem really can just rock up and make itself known. So with this question in particular, from the get-go, right, for 6 marks, the first thing we wanted to make known on the sketch is that we have identified the midpoint theorem, because us identifying the midpoint theorem is what made this question as easy as it is right now. Apart from that, it was really not a lot of heavy thinking. It was just nothing. This question was really not that crazy, because we have angles that are equal to each other, lines that are equal to each other, and it's talking about area. So the formula areas, they are really limited. You really don't have like a lot of them. You just have to choose between either this one or this one. And then we just did whatever we did. This portion here, the first thing we did was, we see here, they gave us this information. And then from them giving us this information, we knew that the ratio, I think here I meant GB. I wrote C instead of G. Here we said GD, right? The ratio between GD and this GB here, we know that it is like 1 to 2. And then the reason for writing that down was, we said here, line inside our triangle here bisects AB. Therefore, I mean, it bisects AB, right? And we also know that AH and AG, the ratio is like 1 to 2. From there, we're able to say that we have identified the midpoint theorem. We identified the midpoint theorem because these two were equal, and we have parallel lines here, right? And we know that this is half of that whole line here. And we showed it in that other portion up here, where we said that as long as the ratio between one line of a triangle and another line of a triangle is just 1 to 2, everything else is going to be 1 to 2. So I think, without saying too much for this question, that was that. It wasn't too crazy. I think it was a good question, to be honest.